I wanted to give you a quick demo of the application that we're going to be building in this course. Now, as you can see, this is the front-end application. There's an entire back-end application that is supporting this front-end application, and we won't be covering that back-end in this demo, but we will be seeing all the features that we're going to be building in the front-end application. So as you can see, this is a user management application. You have a list of users and you can update, create, or delete those users as you wish. As you can see here, this application has two tabs. There's one here where we have all the users, and then this other one where we have the profile of the logged in user. So if we go back to the list of all the users here, you can see we have this nice table with all the users, and we can take a look at their information. So if I click on one of those users, you can see all of their information come up. We can see when they joined, when they last logged in, what role they have in the application, and if their account is unlocked, etc. So you can also see that we can also edit those users. So if I click here, I can actually edit these users. However, I can't edit the role. You can see the role is locked. Okay, if I click on it, nothing happened. Now the reason this user doesn't have access to do this, it's because of the role of this user. So if we go back real quick and check out the profile of this user called Beth, you can see down here, Beth is the manager. And to the right over here, you can see that for this role, she can only read and update users' information. And that explains why when we go back to the list of all the users, we don't see a button to add a new user or delete a user, because she's not allowed to take those actions in the application. She can actually update, like if I go here, I can actually update this user here. If this user is inactive, I can go ahead and make that user active, and I can even change their name to John. Okay, so I can change the name, save. As you can see, I can update, but I can't create or do anything like that. So let's go ahead and take a look at Morty. So Morty here is a simple user, as we can see, right? So I'm gonna go ahead and sign out, and then I'm gonna go ahead and log in with Morty. As you can see, we can't log in with Morty because Morty's account has been locked. So if we go back and log in with Beth, again, Beth is the manager, we can see Morty's right here. And if you click on Morty, you can see it says account locked, okay? And that's why this is red, because Morty's account is locked. So I'm gonna go back, and then in Morty again, I'm gonna unlock Morty's account. So I'm gonna click on this and then save. And if we check Morty again, you can see now account unlocked. Okay, so let's go back and log out with Morty. So I'm going to select Morty, and then I'm going to log in. As you can see, we're logged in with Morty. Now you can see the application looks exactly the same. However, if I click on this edit here, you can see everything is locked. I can't click on anything. Everything is grayed out, and then it says read only for everything, which means this user only has permission to see the information, but they can't change or update or create or delete the information. And if you go back to his profile, you can see here, Morty has role user, and Morty can only read the information. Okay, so you can see that Morty can't do anything. You can click here, there's nothing you can do, everything is locked. Now let's take a look at Summer. So Summer is the first user. You can see that Summer is an admin. So I'm gonna go ahead and log out and then log back in with Summer. So let's go here, and I'm gonna log out, and I'm gonna do Summer right here, and then log in. Now you can see the application looks a lot different. We have this new button here, which is a button to add new user. And then we have this edit, which we've been having. And you can see everything is now unlocked because this user is an admin. And if we go back to this user's account, we can see that they can update, they can create, and they can read, but they can't delete. So if we go back again, we can see that the delete button is there. But if this user tries to delete, they can't delete, and that's why I leave this button here. I could have just gotten rid of this button altogether, not show it unless you have this permission. But I'm showing it here so that you can understand, the implementation of this. So if I click on delete, can't delete. I can also search all the users. So if I type Rick, you can see as I type, then the list is filtering. And if I put Summer, you can see the list filters itself. And I can also reload all the users. I can click on this and all the users reload. And I don't know if you guys noticed, but I have this new settings here now that I didn't have when I was logged in with a user that wasn't an admin. So now I can click here, and as you can see, I can change the user's password by just passing in their email here. And we can check this out real quick. So if I go down here, I select Jerry, and I get Jerry's email, and I go back. If I put some random email that doesn't exist, it's not gonna work. And if I put the real email, gonna take some time because it's working on the backend. As you can see, we send an email to this person here, and they would actually get a real email in their email. Obviously, this is a made-up email, so I hope nobody has this email because I don't want to be spamming anyone. But they would get a real email. So now the last thing I want to do is to deactivate a user. So if I go here again for Beth, and then I make her inactive. So I'm gonna uncheck this. As you can see, it changes automatically, and then I save. Now Beth is inactive. Now if I try to log in with Beth, you will see that it says the account has been disabled, okay, because she's not active. And the same will happen if the account is locked. If the account is locked, it'll say, hey, the account is locked. You can't really log in. So now what I want to do is to log in as Rick. Okay, so I'm going to show the difference now with Rick. I'll log in. As you can see, the application looks exactly the same. However, if you go to Rick, you will see that Rick has this delete permission because Rick is not only an admin, Rick is a super admin, and only the super admins have the delete permission in addition to everything else. So I can come here and then delete a user. So let's say I want to delete Jerry. I can click on the delete. As you can see, it works perfectly. And then, of course, I have all the other function. I can update password. I can filter the users. I can add a new user. Just gonna add some random guy here. And then I can select whatever I want them to be. And then I can make sure they're active or not, and then save. You can see this user now is entered. And I don't know if you noticed, but you can see here, this user has this avatar. Okay, so by default, we're gonna use the user's username to give them a very specific avatar according to what their username is. So if I enter someone else, you'll see the avatar is different. And I can show you that real quick. So if I enter some random person here, give him some random username or whatever, and then give him a role and then save. You can see now this avatar is different. That's because we're reaching to some external API and then give him, a specific unique avatar. And of course, I can go to my profile. I can update my information. Like I can put a middle name here or something and then save. I can update my picture. Click here and then you can see the picture is updated. I'm going to put Rick back because this is not Rick. Select the picture again, updates back. And so on. So now let's go ahead and log out with Rick, and I'm going to show you what happens if we try to log in with Rick with a bad password. So I'm going to remove this password and I'm going to put some random password here for Rick, and I'm going to try to log in. So I'm going to do that. 1, doesn't work. 2, 3, 4, 5, and I'm going to try again. Now the account is locked. Okay, so it says your account has been locked. Please contact administration, because I try to flood the application and we have a mechanism where we listen to how many times someone is trying to log in. And this is a mechanism that I created so that we can mitigate brute force attack. If someone is trying to log in with, some correct username and they don't know the password, they're going to keep trying and trying until they get it right. So we want to mitigate that, and that's just mitigating brute force attack. So I'm going to go ahead and log back in again with Beth. If she's not disabled, yep, she was disabled. So I'm going to try Morty. And as you can see here, if we take a look, we can see Rick is locked. Okay, you can see we didn't do this manually. It happens because this person or this user, Rick, was trying to log in multiple times within a specific window, which I set to 15 minutes. So within 15 minutes, if someone's trying to log in like 5 times, their account is going to be locked. And that's what happened to Rick. So I think that's everything. I feel like I'm forgetting something, but anyways, that's the whole point of creating, a course about security, because ultimately this is what you want to do. You want to build an application with very fine-grained security where different users have different permissions, and this is what you would see in a real-world application. So I hope you guys are excited. There's really a lot to cover in this course, and I'll see you in the course. I want to talk a little bit about some of the prerequisites that you need to have going into this course. And before I talk about any technologies, I want you to understand that I'm only expecting you to be very familiar with those technologies. You don't need to be an expert in any of them. but as long as you're comfortable and you're not going to be super confused once we start using them, you should be good to go. So the first one is going to be Java. I'm going to be using the Java programming language to build the entire backend. So I'm expecting you to know Java to some degree and you're comfortable with the language. The next one is going to be Spring. Spring is a very popular Java framework for building mostly web application. You can do other things with it, but it's mostly used for web application. And since I'm going to be building a backend web application, we're going to be using Spring to do that. So I'm expecting you to understand Spring, some of the basic concepts like inversion of control or dependency injection and things like that. So as long as you're comfortable, you're familiar with Spring, you know what it is and you know why it's being used here, then you should be good to go. The next one is going to be HTTP. Now, the reason HTTP is on this list is because we're going to be building a front end and a back end application, and the communication between those two applications is going to be done over HTTP. So I want you to understand HTTP, understand how it works, and certain things about HTTP like headers and request and response and things like that. Next one is going to be HTML. Of course, if we are building a web application, it only makes sense that we're using HTML. So you have to understand HTML. Technically, HTML is just all the content you see on the web page is rendered using HTML. Next one is going to be CSS. Now we can talk about HTML without CSS. CSS is for styling and animation. Actually, you can do a lot of animation with CSS right now. So you got to understand HTML and CSS. And of course, JavaScript. JavaScript, you really have to understand JavaScript because we're going to be using TypeScript, which I'm going to talk about in a minute. And TypeScript is just a superset of JavaScript. So it's very important that you have a very good, solid understanding of JavaScript going into this course. Next one is going to be Bootstrap. Bootstrap is a very popular library for styling when it comes to web application. So I mentioned CSS. We will be using CSS to, put in some custom styling in the app, but most of the styling is going to be done using Bootstrap. So that's why it's listed here, because I want you to understand, to be familiar with it, and you know what it is. Next one is going to be Angular. Now, Angular is the framework that we're going to be using to build the entire front-end application. So Angular is a JavaScript framework. It's got all the features you need to build any front-end application, enterprise level or something simple. So very popular framework. We're going to be using it in this course. And of course, I'm expecting you to be familiar with some of the concepts of Angular, like, services and components. Next one is going to be TypeScript, and that's because we're using Angular. Angular uses TypeScript. So TypeScript, again, is a superset of JavaScript. So if you really already know JavaScript, I'm assuming you pretty much know TypeScript, because TypeScript, it's like a superset of JavaScript. And what it brings to JavaScript is really type. Like you can have things like classes and interface. So again, good understanding of TypeScript would be very valuable going into this course. And lastly, I'm expecting you to understand MySQL Community Server, because I'm going to be using it. It's free. It's very, very popular, and we're going to be using it as our data store. Remember, we're going to be building a front-end application that's going to communicate with a back-end application, and that back-end application needs to store all the data in a data store, and that's going to be MySQL. We're not going to be writing any queries or anything like that. I just had to put it on the list so that you're aware of what data store we're going to be using, and you can brush up on it if you want, just so you know what MySQL is. And that's pretty much it. I mean, as long as you're comfortable with those technologies, you've heard of them, you're familiar with them, you're not going to be super confused. And if you're super confused about something, you can just Google it. But again, I'm just expecting you to some degree, know those technologies. I want to talk about what you need to have installed on your computer to follow along in this course. So I'm going to go over every single piece of software you need to have installed and configured on your local machine. and I'm also going to show you where you can go and download and install everything. So I'm not going to go through the process of showing you exactly how to install like Java on your computer. You can definitely find like hundreds of resources online to do that. And since this is not an entry-level course, I'm assuming you already know how to like install Node.js or something. So the first piece of software you're gonna need is going to be Java. So you need to have the JDK installed. That's the Java development kit. So we're gonna be using Java to build the entire backend. So it only makes sense that you have the JDK installed on your computer. Next thing you need is going to be Node.js. Angular needs Node.js, so you definitely need to have Node.js installed on your computer whenever we're gonna be building the front-end application. If you don't want to do it right now, that's fine, because we're just gonna be working on the backend. But if you're gonna install, just install everything in one go. So yeah, you definitely need to have Node.js installed. Next, you're gonna need the Angular CLI. Now, once you have Node.js installed, you will have access to something called the Node Package Manager, and that's what you're gonna need to install the Angular CLI. Now, the Angular CLI, it's not absolutely necessary, but I would highly recommend you have the Angular CLI installed, because when you're working with Angular, it makes everything so much easier. So definitely have the Angular CLI installed on your computer. Next, you need to have MySQL database installed. So this is gonna require a little bit of configuration, because you need to set up a user and a password, or you just need a password for the root user. If you don't want to use the root user, which is not recommended, then you need to create a user and then set a password for that user so you can access the database. But I would say that's not really necessary unless you plan on going into production. You don't necessarily, you can use the root user, that's fine. I mean, you're just learning, you're taking a course, so that's not going to hurt anything, and it's only on your local. But it's going to require a little bit of configuration. It's not as straightforward as like Java or Node.js, but you definitely need to have MySQL installed, because that's going to be our database where we're going to store all the data. Next, you're going to need to have an IDE, and I'm going to put two IDE here. So you can have either IntelliJ or Eclipse. It doesn't matter to me. Either one is fine. I'm mostly gonna be using IntelliJ. It's really powerful also, but I've used Eclipse for like a very long time. I'm very comfortable with Eclipse, but I have to give it to IntelliJ. The people at JetBrains, those are the people who created this ID. It's extremely powerful. So you can either install IntelliJ or Eclipse. Doesn't matter to me. They're both great IDEs, to be honest. So yeah, either one of them is fine. Next, you need to have Visual Studio Code installed. That's just a text editor. But again, for all those three IDEs, you don't necessarily have to install them if you don't want to. If you just want to use Notepad or Notepad++ or any other text editors you have on your computer, if you're on a Mac or Linux or whatever, that's totally fine, as long as you're comfortable with that. IDEs they just make developing so much easier, because they have code completion and things like that. It would be a good idea to have an IDE, but if you don't want to, that's fine, as long as you have something to write the code in. I'm totally fine with that. But Visual Studio Code is extremely powerful. Like, they have Git integration, and it's amazing. So definitely would recommend you have Visual Studio Code installed. And last but not least, you need to have Google Chrome installed. Now, I wouldn't say Internet Explorer or Edge. I don't think those are going to be very good for, at least for this course. But if you have Firefox, that's fine. But I'm going to be using Google Chrome, and I'm going to be doing a lot of debugging in the front end using Google Chrome, the tools that you have in Google Chrome. So I would definitely recommend you install Google Chrome. But if you don't want to, you want to use Firefox, for instance, Firefox is really nice. You can keep that as well. But those are just the things that I'm going to be using. And if you really want to just do everything that I'm doing in the course, yeah, sure, go ahead and do that. But if you're experienced, like things, I mean, you don't necessarily have to install like IntelliJ or Eclipse if you don't want to. Now let's take a look at where you can go ahead and download those software and then install the software on your computer. So for Java, you have to go to oracle.com. Once you get to Oracle, I mean, it's going to be pretty straightforward. You can click on this menu right here, and to the right down there, it says download. You can click there. It should take you to the download. And if you scroll down a little bit, you'll see Java. You can click on it or just scroll down. And here's the Java develop for the JDK for developers. So you can install it, just click on it and just follow, accept the license, and then just follow the prompts. For Node.js, you have to go to nodejs.org and you have to download the recommended for most users. If you don't want to, you want the latest features, that's fine. Either one will work in this situation. But most people would use the most stable version, which is this version, the one that is for recommended for most users. So most people would use this instead of this if they want something more stable. But again, I mean, you're not really gonna have a lot of problems if you want to go with the latest features. But just to be safe, just go with the recommended for most users. And that's just, I think if you just click on it, you'll just download, and then it's an executable file. You just go through the prompts again. Very simple. Depending on your operating system, if you have another operating system like Linux or something, you might have to click on here and it will take you to different downloads. So once you have that installed, you can go to cli.angular.io, and this npm, you will have it once you have Node installed. That's the Node package manager, and all you have to install is the Angular CLI. And this G stands for global, meaning you can open your command line anywhere and just run any ng command, which is the CLI command, and it will work fine. That's what that means. That means you install it everywhere on the computer. So once you install Node.js, you just have to come in here into cli.angular.io and then install the Angular CLI. Now you only have to run this first command. You don't need to run those three. We're not gonna be creating an Angular application just yet, so you just have to run this first one. Now I want to show you why I'm doing this. So let's go into the official website of Angular, so angular.io, and let's do maybe setup or something. So set up local environment. So here, if you click on here, right, you can see for a prerequisite, it says, before you begin, make sure you have Node.js installed. So once you have Node.js installed, then you have the Node package manager, which is npm, and then you can install the Angular CLI right here. All right, and then you're good to go to create your app. So that's exactly what I just showed you. Now for MySQL, you just have to go to mysql.com. Once you get there, just go to download, and then you can download the community server from here, and then go through the prompts again. Just set a user if you don't want to use the root user. If you want to use the root user, that's fine. You'll just have to set a password for it. Next one is IntelliJ. So you just have to go to jetbrains.com and go to tools, I believe. Yep. And then down here you see IntelliJ IDE, and you just click on that, and then you download it right here. It's really, really powerful IDE. Very nice, beautiful UI, very powerful. So yeah, that's where you get IntelliJ IDE. Next is Eclipse. Well, you don't need to have both of them, but I'm just giving you the flexibility. If you like IntelliJ, go for it. If you like, Eclipse, go for Eclipse. You just have to go to eclipse.org and then click on this download here. It will take you to the download page, and you just have to click again, or maybe it's gonna start automatically the download. So maybe, I don't know, maybe they changed it. This looks really nice. That's a new website. I didn't even know it looked like this until I put in the URL and then fetch their website. So that's Eclipse. Visual Studio Code, you just have to go to code.visualstudio.com, and then here we go again. Simple download an executable file. If you have a different operating system that's not Windows, I think by default it will be your operating system. I think they run some code in the back end or maybe in JavaScript to find out what your operating system is. So they'll just show you the default here. Otherwise, just click your operating system here. And again, Chrome, you don't necessarily need to have it. If you have Firefox, that's fine. I would not recommend Internet Explorer or Edge, but you can just go to google.com/Chrome and you can have Chrome downloaded here. And one last thing I want to show you is the emulator that I'm going to be using, and it's called cmdr.net. So if you go over this website, you will see this page and you can install it if you want. That's just the one that I have it installed here. That's this little icon you have down here. So it looks like this. It's just an emulator. You can run some Unix command even if you're on Windows. That's why I like it. And you can, one of the best thing about this is the copy paste. I can just do Control C, Control V. Like you can't do that using the command prompt. And if you're a Windows users, you know what I'm talking about. So I'm going to be using this. So the reason I want to show you this is because I want to show you exactly how to check to make sure that you have those things I just talked about installed on your local computer. So I'm going to open the CMD here, and I need to check for Java. I need to check for Node.js. I need to check for Angular. So to check for Java, after you've installed everything, you just have to do, let me make this a little bit bigger so you guys can see. So you type in Java, and I think it's dash version. And there you go. So I have version 1.8. That's good enough. I think if you do download Java like right now in 2020, it's going to be version 13. Which is also fine, but at least you need to have 1.8. Once you have that, you should be good. So if you type in the command java dash version and you have something back, you didn't get an error, that means Java was installed. Next is Node.js. So I'm going to go ahead and clear this real quick. So if we do node, I think it's dash V for node, and there we go. I have 12.14.1, which is the latest version as of February 2020. So let's go ahead and clear that. Now, if you want to check to see if you have the Angular CLI installed, you just have to do, I think it's ng -- version. And there we go. So let me make this bigger. So yeah, they have this nice Angular CLI, and here's the version for the Angular CLI command line interface, and here's my Node version and some other information about my operating system and so on. So that's all you need to have. Once you have this software installed, you should be good to go. Let's go over a brief overview of web application. Since we're going to be building a web application in this course, so it's very important that you understand at a high level the architecture or the overview of modern web application. As you might already know, for any web application, well, maybe not any web application, but for a typical web application, there's going to be a front end, right? And there's going to be a back end, and of course there's going to be a data store. That's going to be where your database, right, where everything is going to be saved. Now the front end is going to be HTML, CSS, and JavaScript. In our case, we're going to be using Angular, and when you deploy the app, everything is going to be bundled into HTML, CSS, and JavaScript with Angular. So really, at the end of the day, everything gets converted into HTML, CSS, and JavaScript. And then you have the backend. You don't always have the backend. Typically you do, but you don't always have the backend, and I'm gonna give you a quick example of that in a minute. So you usually have a backend, right? And then this backend can be, I don't know, Node.js, C# or Java. It can be any one of those technologies or something else for the backend. And the data store can be, I don't know, MongoDB, Oracle database, DB2, or MySQL. So that's what a typical web application looks like today, and we're going to be building something very similar. We're going to have a front end and the back end and the data store. So a quick example, for instance, sometimes you only have the front end and you don't have the back end or data store. If you have an application online and it's only showing content, right? You don't have any form, you don't take any customers information or anything like that. You only showing information, phone numbers, if someone needs to call, or the description of something, then that's only front end. You don't need the back end. Now let's say, for instance, I have like I don't know, a blog or a small company, right? I'm displaying information, like I'm showing information, but I also want to get the user's information. For instance, I can have a contact form, right? And this form takes your email, your name, and the message, for instance, right? Let's say you're just contacting me because you have a specific question or something. Then we can build that all with the front end using HTML, CSS, and JavaScript. You can use JavaScript to send emails. But usually you would have a backend, and this backend will be listening to any request that gets sent to, for instance, if you have an endpoint for send email, for instance, right? So if I'm a user, I'm using your application, and I'm like, you know what, I need to contact this guy because I want to work with them, or for whatever reason, or whatever. And then you go in, and then in the UI or the web or the phone, whatever it is you're using, you put in your email, your name, and then the message, right? And you click send, for instance, or submit. Once you do that, then the front application will send a request to the backend, and the backend will be listening for that request to come in. So every time there's a request, the backend will take it and process it, and that's exactly what typically happens in a web application. So that request would come in, the backend will take it, and then the backend will just process it, maybe send you back a confirmation saying, hey, your message was received, or something like that. Maybe you might want to save the customer information. You might want to save it in a database because you want to use it later. Maybe you want to send out emails for promotions or something like that. So that's a good case scenario where you would want to save that information. And here I have only database, but you can also store information in the file system. Like you can take that information and then take the user information, put it in a file system, like a text file or something. But typically it's going to be a database. Databases are free, and they're really more powerful, more perform better than file system when accessing and writing to the file system. It takes a little bit more time. So again, that request would come in, the backend will take it and process it, maybe send a confirmation email or something, say, hey, we're gonna get back to you, or something like that. And then this backend will also take that information and then save it somewhere in the database or in a file system or somewhere else, so that we can use it later. So this is the typical overview. This is the typical design of most modern web application, and we're going to be building something very similar to this. So in our case, it's going to be Angular, again, that gets bundled into HTML, CSS, and JavaScript. For the backend, we're going to be using Java, and for our data storage, we're going to be using MySQL. Let's take a closer look at the front end. So the front end is usually what you see either on your computer or using your cell phone, right? If I open my computer and I go over to a browser, that's the actual client that I'm using, and I access Facebook, for instance, right? And I put in my username, password, or whatever, and then I log in. Once I'm in, what I am seeing is the actual front end. That's what I'm seeing. That's the interface that I can interact with. That's the front end of the web application, which is Facebook. So this web application is really the actual HTML, CSS, and JavaScript coming to me from some Facebook server somewhere around the world, depending on my location. So that's exactly what the front end. The front end is, just the HTML, the CSS, and JavaScript coming to you. Of course, there's more to it. There's logic, that tells the browser to show you this or that, tells JavaScript to do this and that. That's something completely we would have to look at in detail, but that's not the point of this. But what I'm trying to tell you is the front end is what you see. Like if you go on YouTube, whatever you're seeing, that's the front end. That's the HTML. That's the CSS. That's the form. That's the media being played. That's the front end, right? Maybe the media is coming from a server, probably, but the front end is the display. It's what you see, and of course all of that is in a server. And the communication between the client, either you and your computer or the phone, that communication between the server where the HTML is stored in your device is done over HTTP. It uses the HTTP protocol. Like I just gave you this Facebook example. If I go on www.facebook.com, this is going to be prefixed with HTTPS, colon / / It's HTTPS because it's a secure server. So you're using the HTTP protocol so that you can access HTML, CSS resources on some server somewhere. Again, of course, there's going to be more logic to, for instance, if I log into Facebook, I'm not going to see somebody else's account information. I'm going to see my information. So the server processes the request and find out who I am and then give me the information that I'm supposed to be seeing according to Facebook logic or whatever principles that they determine what you see. So again, that's the front end. Let's take a closer look at the backend now. So the backend is usually where you're gonna have all your logic for your application. So most of the core logic of the application is gonna be in the backend. You can have some of the logic as well in the front end. You definitely will have some of the logic in the front end as well. But most of the core logic of the application and the access of your data is gonna be done using the backend. So the backend can either be Java, C#, Node.js or C++ or whatever the case might be. But the point is, the backend is where most of your core logic, or if not all your core logic, is going to be at. That's going to be the backend. And that backend can be accessed in many different ways. The first one is going to be programmatically. So you can have another application calling the backend, right? That application can use HTTP, but it doesn't necessarily have to. So you can have, code accessing code from one application to another. So you can have that. And then of course you have HTTP, which is very common. So you can have HTTP calling the backend. For instance, if you have a front-end application, it doesn't necessarily have to be any framework or Angular or anything like that. You can have plain vanilla JavaScript, and then you just make an AJAX call to some backend application. So that's what we're talking about here when I say HTTP. Or you can access it using some command line interface. So you can build your application and you can just have access to it using some command line. You can build a CLI for it, which stands for command line interface. You build it for the application, and then you can interact with the application that way. And interaction can be done in many different ways. I'm just listing just a few here, but I'm sure there's a few more ways you can access your backend application. And of course, all this backend application is going to be hosted on some server somewhere. Now, I keep mentioning server. I don't want you guys to be confused. So technically a server is a computer, but the primary goal for it is to host application. It's not designed to be used by people primarily. I mean, I guess, yeah, by people, but it's mostly designed for other applications. So in the server, you're usually going to have some application leaving on that server, and it's not something that it's for everyday use for some random person. So that's why the server is technically a computer, but it's mainly designed to host other applications and things like that. So the big picture is this. You have your backend application, either Java, C#, Node.js, whatever, C++, whatever the language is, and that's where most of your logic is going to be living. And then all of this is going to be, of course, packaged and deployed to a server. And then the communication from your application to the outside world can be done using another application, or using HTTP, or using some command line interface, or some other ways. So the data store, let's talk a little bit about the data store. Now, the data store here is a very broad term, because this term actually means like a paper file. Like, for instance, I can take a piece of paper and write something down, put it in the drawer and use it later. That's a data store, right? And that can also be, in terms of computing, that can also be the file systems, emails, servers, where you have all your emails stored in databases, right? So in our case here, we're not going to be talking about paper or the file system, but we're mostly going to be focusing on databases, so relational databases. Now, the data store, as you can see, is going to be like any data store out there that you can either buy or use for free, like Oracle DB or MySQL or Microsoft SQL Server or anything else, right? That's going to be the actual database. Now, that database is going to live on a server. Of course, all these applications, they need a place to live, like a place to be. And that's always going to be, in like 99.9% of the case, that's going to be a server. Now, you have to understand that the data store, it's like a repository for persisting data and storing data, or any collection of information. That's where you're going to just put some information. So for instance, I can have a form, and I'm taking information from a customer, like name, email, phone number, address, and then I can just take that information, probably apply some validation to make sure that they're giving me the right information, and then take that information and store it in a database, because I need to use it later. So that's the data storage. And of course, you usually access the data storage or the databases using some sort of a application. You're usually going to have an application where you're just going to have that application access the database. Now, you can also access databases over HTTP, like on the internet. Like, for instance, if you have like a MySQL database on AWS, for instance, which is a cloud, so they're probably going to give you URL that you can use and then access that database, but they just really map that URL to an actual application that then does, the actual connection with the actual database. So at the end, it's going to be some sort of an application accessing the database for you. So, and that connectivity, usually it's going to be like a very specific implementation depending on what application is accessing the actual database. For instance, the connection to databases is done using something called Open Database Connectivity, and that's just really like a standard application programming interface that you can use it and then implement it. So, for instance, let's say you're using Java to access some database. You're gonna let's say your database is MySQL Server, so then you're gonna use the driver for that MySQL Server. If you have Microsoft SQL Server, then it's going to be a different driver, but they're using the same standard application programming interface for accessing the database, but they just have a different implementation. So that you have to understand. So the data storage, that's very high level. It's just where you're going to have all your data stored, and you can retrieve this data later at a later time if you need it. Of course, well, that's exactly why you're saving it, because you're going to need it later. And the Open Database Connectivity, it uses TCP, IP, and then for security using SSL. They do a lot of things with it just to make the connection happen. But bottom line is, this specific standard is using TCP with IP and then SSL for security, because most production database, or any time where you have secure information, you probably want to secure a database, because that's exactly where everything lives. Like, that's where all your data is. So you always want to make sure this is very secure. So I have the application on my computer, and I'm just gonna click on it, and I'm just gonna right click on this POM file. As you can see, it's got the IntelliJ logo on it. So that means that IntelliJ is the default application this XML file is gonna be opened with. So I'm just gonna right click it or double click it and click on open, and that's gonna launch the IntelliJ IDE. All right, so here we are. It's still loading. All right, so here's the main folder. Let's go into source and main Java, and here is the default package name, and here's the main application file. So I'm gonna close that in a little bit. As you can see, it's a Spring application with the default application file. That's gonna be the starting point of the application. So let's go ahead and create a new package so that we can add all of our domains. So I'm gonna go to package. I should definitely make this bigger. So go to settings, file, and then settings. And let me see how big this is. This is not big enough. Maybe this is 14, maybe. Apply. So that's gonna make all of this, the side panel, everything on the side panel bigger. So I guess that can be even, let's make it 15. Apply. Okay, so you can see everything on the side panel. And I think if I go to editor and I go to font, I can change the font of the actual code. So right now I have it at 20, maybe 22. It's kind of big already. Apply. Okay, so that should be good. So right click on the main actual package name and go under new and then package. So we're gonna call this our domain. As you can see, it just already started the complete package name, and that's what we want. So domain. So you remember in the application demo, we were just showing a bunch of users, right? And again, that can be anything. It can be anything you want. And that's also a really cliche application, like managing something, managing, I don't know, courses or students or user. You know, because the focus of this course is mostly on using JSON Web Token to secure the application, but the application itself doesn't really matter. The only reason we're building all of this application is because that's just how I like to teach. I like to actually like show you an example of in the real world, like from start to finish. And that's I think, at least in my opinion, that's one of the best ways to actually learn something. So let's go ahead and create our user domain. So we're gonna go to new Java class and we're gonna call it user, enter. All right. First thing is our user class is gonna need to implement the serializable. Now, the reason we need to do this is because this class is going to be going from being a Java class into a different stream that can be saved into a database. And that's why we're implementing the serializable, because it makes this transition a lot easier when you're moving from one, I guess, type of representation of the data into another. So that's what I'm doing here. All right, so first thing, we're gonna need an ID for this user. So the user is gonna have an ID, and that ID is gonna be served as their primary key in the database. So we're gonna create an ID that's gonna be a long, and next one is going to be an actual user ID. As I showed you in the application, there's like an actual ID that you can actually show to the customer. Now, the reason we're having two IDs is because the first ID, which is this ID right here, right? That's the ID for the database. So that's the primary key, and it identifies that one user. So that's very kind of critical piece of information, because if you know that user ID, you can really go straight to that user. So that's a little bit risky. So we're gonna create a separate ID. In that case, that's gonna be a long, and it's just gonna be some random number. So let's just call it, for instance, user ID, and that's supposed to be lowercase is I. Okay, so that's the difference between those two IDs. And this user ID can be anything else. Like for instance, in your company, you might have like a prefix in front of it. So you might have like, I don't know, CWJ dash and then the ID number, or with the ID number, or anything like that. It's just something that means something in your company. Like it means like this customer is this, and you can use that number to do whatever to identify a customer in your company, but it's not the primary key that is used to save the user in the actual database, because you don't want to expose this information at all to the external world. But there's no, I mean, you can have other ways to look at the customer using this ID, but at least I guess you can still use it to, I guess, do malicious stuff with the database, but at least it's not the primary key, and that makes a big difference, because the primary key is going to be used in different tables, so it lessens the vulnerability a little bit. Okay, so let's give this user like a first name, which is going to be a string. So let's do first name. Let's give them another string, which is gonna be their last name, for instance. And let's do maybe username, because we're gonna need that username. And let's do a password. We're also gonna need a password, and that's gonna be a string, so password. Let's do an email, because we need to send them an email. Well, we need more personal information, so let's do email. And we will use this email to send them an email whenever they sign up or they renew their their password or something, or just use it if we need to send out information to them. So this is the representation of a user when we're collecting information about them, and all of this information, of course, is going to be saved in a database, retrieved at a later time whenever we need it, and things like that. So another, let's do maybe a profile image. So that's going to be a string, and let's do profile image. That's actually going to be URL, so let's do profile image URL. So for the user, they're going to have a string that's going to be like a URL that's going to point to the actual location of their user profile, which is going to be like a picture. So that's what this is. And let's do another private last login date. So last login date. Actually, just this should be a date. So that's not going to be a string. Let's make this an actual date from Java util. Okay, so make sure you have date from Java util imported. And let's give them another date that's going to display the actual last login date. So let's call it last login date display. So this is going to represent their last login date, and this is going to represent the actual date that we're showing as their last login date. That's not right. Yep, like this, last login date. So you will see why I have these two in a minute. This is going to be the last time they log in, and this is going to be the actual date that's going to be used to show when they log in, and you'll understand why I'm using two of them in a minute. And let's give them a date when they join, so that's going to be join date, something like that. And let's do now another thing we're gonna need, I think, let's see, so we have all of this information about them. Now we need a few more properties on this user that we're gonna use to map to the actual user that is in Spring, because we're gonna use that user in Spring to do a lot of manipulation with the security. So we need to have certain properties on this user that we can set, and then we can map those properties over to the actual Spring user. So one of them is going to be the
actual roles. So let's create a string array for this. So let's do string array, oops, and that's going to be roles, right? So we create a string arrays. That's going to be like a string of roles. So for instance, we can have like for instance, like role underscore user, and then role underscore admin, right? So that's what this is gonna hold. This is gonna hold the roles of the actual user, of this user, and that can be like a string of roles. So that's why I give it a string of roles. And let's do private another string of permission. So that's going to be authorities, right? Authorities. So, you know, beside having roles, we're gonna also have authorities, and I'm gonna show you the difference between roles and authorities, right? So quickly, roles is like role user, for instance, right? And in the role user, you can have like, let me show you real quick. So let's say this is an array, right? So in the role user, you can have delete permission, right? Let's call those, every item in the actual array is a permission, so or an authority, right? So we can have delete, update, create, right? The typical CRUD operation, right? So you can have this. So that's the difference. So this, which holds all of the authorities with that role, is called the actual role, which is why it's called role user. And the authorities is just all of these, like that can exist inside the actual role of the user. And the reason you want to do that is because you might have some situations where you only want a user with delete authorities to be able to delete some information. You don't care about what role they have. So it just makes the entire system more modular. So you can say, hey, I have a user, I'm just gonna give him the role user. I don't care much, and you know what's defined inside the role user. You probably won't have like something like delete or maybe not create, right? So for a role user, you're gonna keep it more simple. So maybe you can have something like read, right? So that's one, read, maybe edit, right? So for a user, you say, hey, for this user, they have two authorities or permission. They can read and they can edit the information, but they can't do anything else. But at the same time, let's say you have like many different roles and they have many different permission, and you can have like the role admin, for instance, having like delete. So you can have a bunch of users and their admin, you give them the role admin. Now there might be a critical piece of information that you only want someone with this specific permission or authority to do. So that's the difference between the two. You might just want to look just for this instead of looking for the actual role. You'd say, hey, I don't care, just give me this authority. If they have this authority, they have access to do certain thing. Or the same way you can say, hey, I don't care, as long as they're admin, if they're admin, they can do certain things. So it makes the entire system more granular. And let's see if we can give them another thing that we need. It's going to be a Boolean, which is going to be is active. So that's going to determine if they're active or not in terms of their account. And let's do private, another Boolean, and is not locked, to determine if their account is locked or not locked. So again, those are all the properties. We can add more if we want. Usually for like big companies, this list is huge because they have a lot of things. But since we don't really have like a real company, when we have like real requirement from a customer, so we just you know, creating whatever we want and adding whatever we need. Like those four, we actually need them. You can use those for security purposes as well. You can say if you log in, I don't know, like too many times in a row, you can't do certain things, and you might want to use the time that they log in last to determine how many times they're trying to log in and all that stuff. So we can add more information if we want. There's no reason to stop here, but since we're just making this company up, so we can stop here. But if we need to add any more information, we can come back and add it in and just create setters and getters for it. So now that we have all of our properties, we're gonna go ahead and just create getters and setters and constructors for those. So I think if I do Alt insert, then I can do getters and setters, and we want to do getters and setters for everything. Click OK. All right, so we have all the getters and setters. Okay, and we need a default constructor. So I'm gonna do Alt insert in constructor. We need the one constructor with all the parameters. So we're gonna select everything again and click OK. And we need a default constructor. So I can just copy this one and paste it down and remove all of this and everything, because this is gonna be the default constructor, so that we can create a null object. Okay, so now once we have that, we can mark this class as a JPA entity. So for that, we need to add some annotation. So the first one is going to be add entity. And that's coming from Java Persistence API right here. So entity. And we also need to mark this private user ID as the primary key. So to do that, we have to do add ID. So that's also coming from Java Persistence API. And let's add some generated value for this. And we want the strategy to be, let's do generation type auto. We can do identity. I mean, in this situation, it doesn't really matter. We're just gonna do auto here. So one last thing I want to add on this, because what we're doing right now, we're just mapping this class as an actual database, right? Well, not the actual database, but as a table in the database. So this is gonna be representing a table in a database for a specific user, and that's the reason I have to do. Let's make this column, because I need to add some specification on it. So let's do nullable false, and I also want to do updatable false. Okay, so very self-explanatory. Entity, which is gonna convert this into a table in a database, and ID is going to make this ID a primary key, and it's gonna be generated automatically. So it's just gonna, I don't know the actual algorithm behind this, but it's just gonna create some random number automatically. And I want this column, which is gonna be this column in the actual database table, to be not updatable and not nullable. So this can never be null, and you can never update it. So that makes it a good, strong primary key. And I think that's all we have to do for now for the actual user class, and that's gonna be like the driving entity for the entire application. So all right, let's see, making sure I'm not forgetting anything. So okay, we have all of our properties, default constructor with all the parameters, and all of our getters and all of our setters. Okay, so that should be it. So once we run the application, JP is gonna pick up on this annotation, and it's gonna map this class into a database with all of those fields as the actual database role, and that's what we want. And again, if you don't know JPA, this course is not gonna cover it. JPA is kind of a topic of itself, but that's what this is doing. And I'm assuming if you're taking this course, then at least you're familiar with JPA. But that's what we just did here. We just mapped this class user as a table in a database. Another domain that we're gonna need is going to be an HTTP response domain. Now, the reason we need this domain is because we want to have a very uniform way to give a response to a user. This is gonna be an API, right? It's gonna be an API that you can access over the internet using HTTP, and every time there's a request, we have to send a response, right? If the response is successful, let's say it's a list of users that we're returning for a successful request, then we can return that specific collection of users. Or if there's an error, we always want our error HTTP response to be the same every time. So we want to have a uniform way of sending a response back to the user. So that's what we're going to do. And this is a very crucial thing in API design, because you want your API to be very consistent throughout the entire application. If you don't do that, for instance, if there's an error, right, and this error is like a very deep layered error that's like bubbling up and you don't know what caused it, so it's gonna throw some random string or some random long error with a very long message to the user, and you don't want that to happen, because that's going to expose the internal workings of your actual application. So you always want to be able to capture every request and then send a response every single time. You don't want the application to just to break. Let's say the user was supposed to send a number, but they sent in a string, and then that caused the application to trip or to cause an exception. Well, you don't want that exception to be sent back to the user, which is a bunch of information about what just happened, because that's going to reveal way too much information about your application, and your security is going to be exposed. So you don't want to do that. So that's why this is very important. So let's go back to the same domain package. We're going to go ahead and right click and go to new and create another class. And this class is going to be called HTTP response, right? So it's going to be the response that we send to the user every time. Now we don't need to serialize this, but let's give it a private int HTTP status code. Okay, so if you're familiar with HTTP, you already know a lot of these things. Things like HTTP, a reason and a message and a status code, HTTP status. So there's like a bunch of code, like for something that was successful, that's 200. If something was created, like if you're saving some information or creating a user or something, and something was created, is 201. And you should know that everything in the 200 range is something that's successful. Everything in the 500 range is some server error, and everything in the 400 range, I believe, is some user error. So maybe they're supposed to go to a specific URL and they don't, and things like that. So that's gonna throw some 400 error. So that's gonna, this int, which is why it's an int, because those are like regular numbers. So that's gonna represent the actual HTTP status code. Let's also let's give this an HTTP status. So let's do this type of, this is gonna be HTTP status, and that's coming from Spring, and that's just gonna be an HTTP status. So we can take a look at this real quick so we can see what's inside of this. So if you press Control and you click on that, it's gonna take you to the actual class, right, from Spring. And you can see it's an enum, like an enumeration, and it's got all the phrase, I believe they call those reason phrase, in the actual code, and the reason phrase again, but represented as a string. So for instance, if I do Control F and search for like 200, you can see 200, it's an okay response. I'm sure you're familiar with that. And the code is 200, and the actual phrase or reason phrase or whatever is okay. And it is 201 for created, and also created for the actual message, so, or reason phrase. So this is what this is. That's why I'm giving it this actual HTTP status. So I have access to this massive information. So of course, since I'm mapping this, the next thing is going to be a reason, which is going to be a string, and it's going to be the reason. Now the reason is going to be, let me go back to this 1 second. The reason is going to be this, like this is the reason. Like it's like a phrase, like for this HTTP status, here's the phrase for it. They have some of them that are deprecated, but you get the idea. Let's search for 500. So here's 500 internal server error, and it's the same. I guess this is always going to be the same, but it's very nice that they build the enum that way, because then we can access all of this information. We can access this. I didn't even have to create my own. I could have just used this, but I just want to show you how I'm mapping everything so that you can have complete control over your API application. So this is going to be that, and let's give it a message, right? So that's going to be a developer message, for instance. Let's do this. Of course, it's going to be a string message, right? So this is going to be your message. So if, for instance, if you're sending some information back, it might just look like let's say it's a JSON, for instance, right? So you're going to do the code 200, right? And HTTP status, right? That's going to be okay, right? That's the Control C. So that's the one for, it's for a 200 OK HTTP status code. It's gonna be OK is gonna be the reason. And then let's say let's do, for instance, the reason, right? Would be like this, and then I guess it's OK because that's how it is in the actual. As you can see, like for 500 internal server error, then it's gonna be this. Like if we do OK, we search for OK, you see OK is OK. So our phrase is also gonna be OK. And for the actual message, right? So we can do message. That's a developer message. So it can say, I don't know, your request. Oops. I don't know why this keeps happening. It thinks I'm making a mistake, so it's trying to help me with intelligence. So your request was successful, like something like that, like some very descriptive message. So this class, this HTTP response, it's going to be looking something like this. So every time there is a request in my application, it's going to return something that's going to have these properties every single time. And this is very important because you want your API not only to have control over what's being sent back to the user in case like there's an error or something, but you have to make sure that you take control over what's being sent back so that you can mitigate. That's supposed to be colon. I just want to make sure I'm sticking to JSON here. So this is, of course, if it's JSON, this is going to be a string. This message is reason code is going to be also a string. It should be, let's say this is also a string for the, and this is, I guess, a number, so it's fine. So that's at least I have to do JSON justice for all my front-end developers. So here's our JSON, right? It's going to look like this every time. So it's going to have a message, it's going to have a reason code, it's going to have an HTTP status, and it's going to have the actual HTTP status code. So that's what we're representing here in this class. So with that being said, let's remove all of this and let's create some getters and setters. So I'm going to do some constructors first, everything, and constructor without any parameters. I can do that. And then I can do some getters and setters. So getters and setters, and I want everything. Okay. All right. So this class will represent all of our response that we're sending back in case the response is something that we're building. Meaning if they send a request and they're asking for like some list of users, then we send them the list. but otherwise we will send them something else. If there is an error, if there is something was successful but there is nothing we're sending back in the response body, then we're gonna go ahead and send them something that's gonna map this actual HTTP response every single time, so that we can have our API be very consistent. Okay, so that's that. And this is not gonna be mapped to a database. This is gonna live in the application itself, so we don't need to add anything on here. We don't need an ID for it or anything like that, because it's not going to be mapped as a table in the database, and it doesn't need the entity because we're not mapping it. And we just need to create the constructors for it. When we need to construct it, these are an empty one. I wouldn't have this at all, because I don't want an empty or the default values for all those properties to be created. For instance, this, if we create an empty object of this class, it's gonna have 0 as the status code, and that's not even a valid status code. And this is gonna be null because it's a string, and this is also gonna be null. So we don't want that. So you wouldn't really have that constructor like that. You would either have the getters and setters and this constructor, because you don't want them to be able to create an HTTP response and send it back, and the status code is like 0, because that's the default for an ent, or the message. Well, the message can be null, but you would usually want to send like a useful message, because that's the whole point of having the message itself. So yeah, I would probably remove that in production, but we can leave it, not a problem. Okay, so that's going to be the class that's going to represent all of our HTTP response.
So when we created our user, we added those properties so that we can map them to a Spring user in the security context, right? So what we have to do now, we have to create one last domain where we can map those values from this user to the actual Spring user that Spring needs to map all the security information, like the password, the username, and if the account is locked, or if the account is expired, or if the user is enabled. So we have to we can do it here. Like I can make this implement this user details that we need to implement, but it can get a little bit messy because we already have a bunch of things on here. So it makes sense that we create a separate class and then just map this class into that other class, so that we can keep this one as clean as possible. So let's go back in the domain for one last time, and we're gonna create another class. In this class, let's call it user principal or something, because that's what Springs calls it, principal. So let's collapse this. So I want this to implement user details, which comes from Spring Security. And you can read here, it says provides core user information and from a security perspective. So that's the one that we want. So it's an interface, so we need to implement all of those methods. Okay, so let's add those in. So as you can see, this user, which is gonna be mapped by our user, it's the user that Spring Security is gonna need to do all the work that it needs to do, and it needs to know all of this information. So it needs to know the username, the password, the account, if it's expired, if the account is locked, or if the credentials aren't expired, or if the account is enabled. Okay, this information is coming from Spring Security. So I'm telling Spring Security what this information is, so that whenever I call on the security to pass me a user and I give him the username, I give Spring Security the username and the password, Spring Security will be able to map those values and determine if they're correct or not. So this is what this is doing. So for this, I'm just gonna go ahead and give it a user. So I'm gonna do private user. Okay, so I give it a user. That way I can pass that user to the constructor of this class. So every time I'm gonna construct a user principal, I can pass this user in the constructor every time. And then from there, from this user that I've given it, coming from our user, from this guy right here, because
this is the guy we know about. This is the actual person in the real world, right? The actual user. And we know their username. We know their password. We're just going to take that information and pass it over to Spring Security. That's all we're doing. So I believe if I do Alt insert, I can add a constructor with that user in it. So whenever I create a user principal, I can pass it this user right here. Okay. All right. So since I have this user, right, I can then give Spring Security all of this other information. So for instance, for the password, I can just say that user, which is the user that just passed in, this guy right here, and then I can get the password. Okay, and I can do the same for the username as well. So here I'm gonna say, hey, Spring Security, whenever you need the username for anyone, just use the user being passed. And this I'm gonna say false. I can leave that like that because I didn't define this. Like I'm not gonna use this in my application. I can if I want to. I can just add it in and then add it to the logic. But I just didn't use it this time, so I'm just gonna leave it to always be actually true. This should be true. If the account is non-expired, true, so that it doesn't fail when we try to log in. If we leave this as false, it will always fail regardless because we return a hard-coded value. So is the account non-locked? Remember, when we define our user, we have is not locked. So whenever we're saving this user, let's say for the first time, they create an account with in our application. So we can set this to false, so that whenever they try to log in, we can use that to build a logic in our application to say, hey, your account is locked on the first time you create your account with us. You need to verify an email, or you need to, I don't know, wait for an admin to give you permission to access the application. So you can see how you can build your entire logic using whatever you want to define. So I can say that is not locked, so that you can see why I name it not locked, because that's how Spring Security is mapping it, and that makes it easier for you to understand because they have the same name. Is credential non-expired true? So for instance, you can have a logic in your application that sets the credential expired for the user, and then, you know, for whatever reason you might want to do that. Maybe after like a few days you want their credential to expire so that they can create it again. Maybe that's a security concern for your company, and things like that. So here we're gonna do the same thing again. That is enabled, is active. So see, I could have called this is enabled, but I just called it is active. So once we have, this is always going to be true because we're not really using that, so we don't want Spring Security to stop us. Say, hey, this user's credential expired. So we always say true because we're not using this for our logic, but we are using the is enable, which is when their account is active. And I'm going to show you how you can stop brute force attack with those values as well. So this is why I like to create a project when I'm teaching a course, because I think it's the best way to learn, like I said before. So you know, you can see this, you can go and read the documentation, you can go find some amazing blog on the internet, and you will see this, you will see things like this. I mean, it might not be like super detailed, or sometimes maybe they are. You know, I've seen some amazing tutorial or blog on the internet, but you know, building a project from start to finish when you write all the code is really gonna solidify the knowledge in your head, and that's what we're trying to do here. Okay, so for this, it's gonna look for that user and get the value. The account is locked, same thing. For the username, same thing. For the password, same thing. For the granted authority, we're gonna do a similar thing. Now, if you remember, we have these authorities that we can get. So we can get those authorities and give them to Spring Security, so that Spring Security will know what this user is allowed to do and what they're not allowed to do. So we have to give Spring Security to say, hey, these are all the permissions that this user has. And with those permissions, let's say, for instance, I can have an endpoint to delete a user. And I can say, hey, this needs a user to have the authority of delete. So if they don't have that authority, they'll never be able to do it, because Spring Security is aware of all the users and their permission. So I can't leave this null. I have to actually get the authorities from our user, which we're going to save in the database, and give them to Spring Security. So let's go ahead and do that. I don't know if you guys are familiar with Java 8, but I'm just going to use Java 8 stream. So let's do stream. Let's take this user, right? We need to get all the authorities, right? And we can take those authorities and map them. Let's go ahead and import stream. For some reason it's not importing, so I don't get intelligence. There we go, stream. Okay, so now I can have map, and what I want to do, so whenever I get all, so let me explain what I'm doing first before I type it out. So what I want to do is return any collection that extends granted authority. So what I'm doing right now, I take all of the user's authorities, which is going to be an array of string, and I'm going to map each one of them as a simple granted authority, which is a string. So I'm going to do simple granted authority, and I'm going to use method reference. So I'm creating a new simple granted authority, and we can go take a look at that. So let's control and click on it. You can see it extends granted authority. So that means that it's a valid thing to return here. It's a valid object to return, because this is a collection of that extends any granted authority. And when you look at our simple granted authority, you can see that it implements the granted authority. So we can return that. And what we want to do, since this is a collection, we want to just collect all of this. So we can do that collect, and we call the collectors from stream.toList, because that's what it wants. So the only thing now, we just have to import map. We have to close this stream first. There. Oh, I have an extra. Okay, so here we are. So we're just gonna take all of these granted authorities, which is an array, a string array. We're just gonna take every single one of them. We're gonna create a new object of this class, and then we're just gonna collect them into a list of string. And that's all we have to do for this class. And again, this is not gonna be something that's gonna be saved in a database, so we don't need any entity or anything like that. We don't need the ID for it. We just have to give it that user, and then give it the information that it needs from our actual user. So that's what we have to do here. And I'll show you how we're going to use this information to lock the account when they try to access the account like 4 or 5 times in a row, like in the same 5 minutes range or something, whatever you want to define. And it's going to be very interesting, and you're going to see that. If we try to run the application right now, we'll get an error. The application is going to complain that we don't have a data source configuration because we have the MySQL dependency. It's going to try to find some configuration in the property file, some configuration to some data source, and we don't have this configuration yet. So we're not going to run it yet because I know it's going to fail. So let's go ahead and put in that configuration so that we can connect to the database that we have, the MySQL database, hopefully that you also have. So let's go back to the application, and we're gonna go to resource and this application.property. Now I'm gonna change this application.properties to a YAML file instead of a .properties file, because that properties file is very repetitive. So for instance, if I were to specify the username and password, for instance, right, I would have to do something like this. So spring data source URL, right, just to specify the URL, right? So I would have some URL in here, like some URL. If I were to now specify the username, I would have to type in the same thing again. So I would do spring data source and then
password, right? So you can see how I keep repeating myself every time for every line. And if I had like 5 different properties I had to set, I would have to type in this whole spring.data source every time. So that's I mean, you can use it if you want, but once you start having like a lot of lines of code in your actual properties file, and you're gonna see how it's gonna be very tedious to be typing everything over and over again. So that's why I'm gonna convert this file to a YAML file, and we don't have to repeat ourselves many times. So I'm gonna right click on this, and I'm gonna go to refactor and then rename. I'm gonna give it the same name. The only thing I'm gonna change is the extension, so that's YML, so that turns it into a YAML file. Okay, so let's specify a different port number. So I like to do server and then colon, not address, that's gonna be 8081, and I want the port, so not the actual address. So server port, you can see I have completion as well. So server.port would be for the properties file, but here you just put a colon and then you go to the next line with a tabulation, and you put the port number. And you're gonna see how this is useful in a minute. So for the Spring data source, we're gonna do Spring.data source, not Spring.data source. So we're gonna do colon, oops, and here it's gonna be data source. Okay, and then here we're gonna specify the actual URL for the data source. So URL. So for our, I'm using a MySQL database, so that's gonna be JDBC and MySQL, MySQL, and that's gonna be colon // and the actual URL, which is on my computer on port 3306. And now I have to specify the name of the actual database, and in my case it's support portal. Now I can specify the password, so I can do password, and you can see how I'm not repeating myself. So for the password, my password is let me in, and I think my username, I don't know why I keep doing that, is root. I'm using the root username. That's not recommended though if you're going into production or anything like that. And that should be everything that we need, but I like to specify some other JPA properties. So let's do Spring JPA. So now you can see how everything underneath this data source belongs to this. So we would go Spring data source and then URL, Spring data source, password, because they all belong under the same data source. But now I want to do Spring JPA, so you can see how I'm back to the data source line, as you can see. So I can do JPA, and then now I can continue with other JPA. So under JPA I can do, let's do show SQL, because I want to show the actual SQL queries that are being fired. So I'm going to set this to true, and then I want to specify how the database is going to be created. That's the DDL, I think it's called the data definition. So let's do hibernate, and I want to do DDL -auto, and this is going to be set to update. Well, actually we don't have the database yet, so let's do create. So once we fire the application, it's going to read this, and it's going to create, it's going to assume that the database is not there yet, and it's going to create it. Not the database, the tables. So once this is to create, it's going to create them. If they're already created, it's going to drop them, which is delete them, and then create them again. So I wanted to create the first time, so I'm going to set this to create. So, and I also have to specify some the dialect. So let's do JPA hibernate and then dialect. So properties, and then here, oops, I have to specify hibernate, and then I can do the dialect. This is very important. So that's going to be org.hibernate.dialect. And I have MySQL 8. So MySQL 8 dialect. Okay, so I think this is all we need for now, just so we can get started. Everything looks good. So if you don't know YAML or anything about YAML, I would definitely suggest that you do a little bit of research, but it's the same thing, just a different format, so that you don't keep repeating yourself, different from the .properties file, but they're technically doing the same thing. So in the last lecture, we edited our data source configuration so that whenever we start the application, it can find an actual data source to connect to, since we have MySQL dependency in our POM file. So now I'm just gonna go ahead and run the application and then access it through the browser. So you can go to the main file, which is the support portal application file, and you can click on here on this little green arrow. It will start it. You can right click and then go to run application, or you can just go up here and then click on this, the same arrow, this, and then it will still run the application. So I'm just gonna click on that, and you can see down here it's gonna start building everything and it's gonna launch the application. So let's just wait for that to come up, and here it is. Make it a little bigger. Here's the Spring logo. And starting, it should be really quick. And as you can see, you already see the Hibernate queries being fired. It's creating the table user, which is what we specify. If you remember, in the user class, we specify the entity here. So as you can see, this is a very nice logo for this IntelliJ IDE. It shows you that this is going to be part of a table in a database, and you can see here it creates the table with all the specified values for the table. And here is Spring Security into action. So if we try to access the application, it's going to stop us because of security. It's going to say, hey, you're not authenticated, because we have the security dependency, and we will need this password to access it. So I'm just gonna highlight all of this and then copy it, and the application is up, and it takes 9.6515 seconds. All right, so let's open my browser and let's go to, you remember we changed the port, so that's going to be localhost 8081, and we don't need to go to anything. We can just go to the root and then click enter. And you can see here, Spring Security kicks in, and it's stopping us, say, hey, you need to be authenticated. So we can just put the default user, and I'm just gonna paste this password in here and then click sign in. And as you can see, it just gives us the default, because we don't have any mapping to the root access to the root URL. So it just gives us this default, say, hey, there's no mapping for this. So now we know the application is running. Let's just quickly return something, just so we know that you know, everything is working fine. So I'm gonna go back to the main package, and then I'm just gonna right click on it and then create another package, and that's gonna be the package for our resource. So I'm just gonna call it resource, and usually call it resource and not controller when it's a REST application, because it's a resource. That's just the name they usually, a standard name they have for it. They call it resource. So if this wasn't like a RESTful application, that would probably be a controller, but in this case it's going to be resource. So in the resource, we can just create a user resource. So that's going to be a new class, and I'm just going to call it user resource. Of course, that class needs to be annotated with REST controller. So REST controller. And I'm going to give it a default path. And for that, I need to specify the mapping for it. So I'm going to do request mapping. And here, I want to specify the value for this. So I can do value, and then the initial, the default for this mapping is going to be /user. Okay, so anything in this class, if you want to access it, you're gonna have to go through whatever the base URL is / user and then / whatever it is you're connecting to. So for instance, if I want to return like some string, for instance, right? So I can create another method. Let's do public that's gonna return like a user. So user, so that's gonna come from our user. Show user. That's just a dummy thing I'm doing just so I can show you something on the screen. Let's make this return no user, and let's just do this. So it's gonna return some empty user. I don't know if this is gonna work, so let's see. If we put get mapping, get mapping, and we want to go to, let's make this user again, so / user. Let's just return, let's make this return some string instead, because this is gonna be empty in the request body, so there will be nothing to show. So, and let's just return application work, for instance, application. Okay, so what we're doing here in the user resource, we're specifying that it's a REST controller, so it's going to be a REST resource, and then we are specifying that the everything here should be prefixed with user. So for instance, if the base URL is like I don't know, www.support portal, so after that, which is the base URL, it's gonna be / user, and then everything else will fall under this. So just to make it clear, I'm gonna change this from user to let's say home. Okay, so let's say this is the home page for under user. So I'm just gonna go ahead and restart this and let it come up. Okay, so it restarted, and I need to grab this again and just gonna copy it. So now we have to go to / user / home. So back to the browser. So localhost 8081 / user / home, and enter. We need to put in the password, so user, and then paste the password that we copied, enter, and you can see application works. Now we're returning this this simple string. Okay, so now we're good. We know the application is working, everything is fine. Now we're just gonna go ahead and get into the security aspect of it, and then start working on this security part. Web application security is a very broad topic, so there's no way we would be able to exhaust it in this one video, but we will talk about what it is, and we will talk about why it's important. So what exactly is web application security? Well, web application security is simply a branch of information security, and it deals with securing web services, web applications, and the website. So it's basically, securing web services and website and web applications over the internet. And because those applications live on the internet, so it becomes very crucial that whatever security implementations that are going to be used to secure those applications, they have to take into consideration the fact that those applications, they live on the internet. And that just changed the whole thing for web application security. Your apps are on the internet, and everyone around the world can access those applications. So because of the fact that those apps, they live on the internet, that just makes everything a lot more interesting, because you have to worry about the entire world trying to access your application or do something bad to it. And we can talk about like different types of security threats. Some of the most common are like cross-site scripting, SQL injection, denial of service attack, and cross-site request forgery. There's a few more, but some of those are the most common that you will find that happen. Like denial of service is a big one. Like that's the one where you need to access a certain service, but some hacker hacked the website or something, and you can't access the service at all. So their service might not be down, but the fact that you can access it just makes, you know, like it doesn't even exist. And you know, there's been companies, they've had attacks where you know, their customers can't access their services, and you know, that one thing for like 30 minutes just bankrupt the entire company. So those security threats, they're very real and they're very serious, and securing web application is definitely a must these days, because there are so many things happening on the internet. Like there are transactions of millions of dollars happening on the internet. There's just very sensitive information being transferred over the internet. So it's very, very important that web applications are secure when they need to be. There's two very important aspects of application security that I want to talk about here, because you really need to understand the difference between the two. And the first one is going to be authentication, and the second one is authorization. Now, it's very important that you understand what authentication is and what authorization is. It's very simple, but you really have to understand it. So what is authentication? So authentication is really validating your credential. It just verifies that you are who you say you are. So if you want to access an application, the application needs to know who you are. And you know, example of that could be giving you like a login form or some other different ways to just get your credentials and then verify who you are as a user. So that's what authentication is. Like you provide your username, for instance, and your password, and then they authenticate you. They say, okay, this is user X or user Y. So that's what authentication is. Now, for authorization happens after authentication. So after you've been authenticated and you access the application, now the application needs to know what you have access to and what you can do. So there's going to be decisions to determine if you have permission to access certain resource or not. And that's what authorization means. Authorization is once you're inside the application, then what are you allowed to do, to what extent you can access certain resource and things like that. And you know, example of this can be just using access control lists. Like for instance, you can access an application, but then if you try to access some admin page, it tells you that the application can tell you that you don't have authorization. So that's what authorization is. It's just determine what resource you can access or to what extent you can access certain things or do certain things in the application. Again, just to recap, authentication verifies who you are, like your credential, make sure they're valid and you are who you say you are. And authorization happens after you've been authenticated, and it determines what you have access to, what resource you can access, and to what extent you can access certain things. And we will see this more in practice once we start building the application. You will see that you know, for certain users, even though they can all access the application, but they can't see all the same things, they can't do the same things, and you'll see that in practice it will make a lot of sense. I want to talk a little bit about JSON Web Token and the components of it. And then after that, we're going to look at how we can use JSON Web Token to secure our web application. So what exactly is JSON Web Token? Well, to put it simply, JSON Web Token is just a very secure way to transmit information from one party or from one application to another as a JSON object, which is why it's called JSON Web Token. And because it's so secure and compact, it's become the standard when transmitting information to a user to authenticate the user and web services. So it's become very popular over the last few years, and it's been used almost everywhere whenever there is like RESTful web services being used and they're trying to authenticate the user, or when one application is being accessed by many different devices and things like that. So Web Token has three parts to it. The first part is the header, and in the header you're gonna have things like the algorithm that is used for the cryptographic, and you also gonna have the type. The type is gonna be JWT all the time because it's a JSON Web Token, and the algorithm can be any different type of algorithm. And in this case, we have ECMAX 256, which is just a typical cryptographic algorithm that is used to encrypt things. So that's the first part. The second part is going to be the payload, and that's where all the user or the subject information is going to be, things like their name and the time the payload, the token was issued, some other claim or permissions or authorities that the user has, and maybe the name of the user and the actual username. In this case is John D24. So that's going to be the payload. And lastly, we're going to have the actual signature, and the signature is only going to be just a 256-bit secret, like some random string that you definitely have to keep very secure because it's used to in the algorithm to encrypt all the information that's going to be the JSON Web Token. And all those three parts, they're separated by a period, and they're just encoded in the base64 URL encoding. So at the end, you will have something that looks just like this. So the purple is going to be the header, and then you have your period, and then the blue is going to be the payload, and lastly in green we have the actual signature. So that's really all JSON Web Token is. Just a very secure, compact way of transmitting information from one application to another. And because it's so secure and compact, it's been used a lot in web services and a RESTful application interface. So how exactly are we going to use JSON Web Token to secure the application? So we have to step back a little bit to the initial picture where you actually have the actual client. So the client is what needs to access your secure application. And then you have your application, which is the actual application that is secure, and you want your client to be authenticated to be able to access it. So the first thing that's going to happen is the client will need to send you a request. So that request, they will have to send their username and their password, just their credential, to some login URL. They will send a post request for that. So then what the server is going to do is the server is going to take that information, the username and the password. It's going to process it, make sure the information is correct. And that's the authentication process that's happening right now that we talked about earlier. So once the application can verify that this person is who they say they are, because they know their username and their password, the application will then send them a response back with a JSON Web Token. So the next step is going to be the application. After verifying all the information that was provided, the application will then send back more information to the user with the JSON Web Token. Now that token has been verified and created on the application, so the server or the application on the right here is aware of that token. So they know that token, has been signed and verified. Now what's going to happen is anytime that the application needs to be accessed, now it requires this token. So if the client needs to access the actual application again, it will need to provide that token that was issued earlier at some point when they logged in. So then let's say, for instance, the client needs to access a list of users, for instance. So he needs to send that request back to the server to get all the users. So the client will then take that JSON token that was provided earlier and then send it with that request. So let's say the URL is like /users with a get request to get a list of all the users. So when the client sends that request,
it will also have to provide the JSON Web Token, because any request that comes into the application, it needs to verify that there is an actual JSON Web Token there, and that token is valid and verified. So once the server is able to establish that this token has not been tampered with and it's not expired or anything like that, it will then process the request to send all the users back to the client. So that's gonna be the big picture at a high level. It's very simple. You need to log in to get a JSON Web Token. So once you provide your username and password, you're authenticated, you get the token, and any time after that, so any subsequent request to the server, you will have to provide that token to the server to verify you as a user. And then once the application is able to verify that token, it will then process the request and send you the response back. And we're gonna implement this whole picture here. We're gonna start by building the factory to provide the token, and then we'll test the application. So it's gonna be very interesting.
What I want to do now is to be able to generate a token. So whenever someone comes into the application, they're going to need to provide their username and their password. And I want to have a factory or a utility or a provider that I can call upon success when they're trying to log in. Once the login is successful, I can then pass them this token that I need to generate, but I need to be able to generate it on the application so that the application can sign it, and you know, that way whenever later they send another request with that same token, I can verify the token and process the request. So we need to create a factory that can generate this token for us so that we can give it to a user once they've logged in successfully. Now, before I go into the factory, I'm gonna go ahead and create a very simple class that's gonna be a constant class, and I'm gonna define some constant that I know I'm gonna need to for the provider of the token or the utility or whatever you might call it. They usually call classes like this a utility class or a provider or something like that. So let's go ahead and define a new package. Let's go new, and then package. I'm just gonna call this constant. Okay, and then in the constant package, I can go ahead and create the class. So I need a security constant class, and in here I just want to define some constant, and you'll understand as soon as I start typing. So the first one, I need the expiration time that I'm gonna set on the actual token. So public static final, and that's gonna be of type long, and let's do expiration time, and I'm gonna set this to 5 days, and you know, that really depends on your specific company requirements. So this is gonna vary for every company. You know, it depends on whatever they want to do. So let me just put a quick comment here. So yeah, whatever they want to do, if they want it for 24 hours, they can do that. Whatever time they want, depending on what security risk that they're trying to mitigate or whatever the case might be. So that's something that you're gonna have to sit down with someone and say, hey, you know, some security architect or something like that, and ask them exactly, you know, for this and this and this and that reason, what should be the time, the expiration time on the token, because that's like one of the key security aspect of the token. The token has to expire. If it doesn't expire, the user can actually use that token indefinitely, and you can already see how this is like a big security problem, because you know, you can use something indefinitely. That's definitely not good. So we need to set an expiration time on it, and you know, that's gonna come down to whatever company policies that you have in terms of security or whatever. So I'm gonna have 5 days, and that's gonna be expressed in milliseconds. So I did Google that, so I don't want you to think that, oh, I know this by you know, off the top of my head. It's 432 a million. And since I think Java 7 or something, you can actually put underscore so that for readability. So 432 million milliseconds is 5 days. So that's the first constant that I'm gonna need. The second one, public static final, and that's gonna be a string, and that's just gonna be the token header. So let's do token underscore header. And this is going to be just bearer. And I'm going to explain what that is in a minute. So bearer in front of the token means that whoever gives me this token, I don't have to do any further verification. I can just take that token and then work with it from there. So public. So that's what that means. So whenever I generate the token, I'm going to put this bearer, oh, not bear, there in front of it. So that means that whoever has this token, they can just give it to me, and I can just make sure it's verified. I don't have to do any further check to see, to see how they got the token. The bearer means they have, I don't know, like ownership of it. Like it's good. They have it. It's theirs. I should just take it and without any question. Like I shouldn't do any further checks to see to determine how they got it. That's what the bearer means. So and you'll see how this plays out once I start building it, and I'm connecting all the dots together. The next constant that I need is going to be the actual token header. So when the request comes in, they log in with their credential. I check the credentials, I make sure they're correct, so they log in successfully, and then in the response that I send back to the user, I actually give him the actual token. But that token is going to be in the header. The JWT token is going to be served to them in the header. So I'm going to create another string, and that's just going to be a custom header, which you can always do, and I'm just going to show you how to do that now. So that is going to be the JWT token header. So we can just call it JWT token underscore header, and let's just set this to JWT I think dash header. Let's do not header, let's do token. So if you look at different existing headers, you will see that they start with an uppercase and then lowercase, and then if it's a two-word kind of token, it's separated by a dash. And that's why, so I'm trying to like stick to the convention. So I'm creating my actual, custom header. That's just the name of the variable, but that's what's gonna be in the header and the request, this string right here. And you'll see, I'll go back and I'll show you, here's our actual custom header, and we're passing in the token into that header. Next one is going to be some other string that I know I'm gonna need. So public, I know there's a way, by the way, to just do public static final, like you do when you're trying to print. Like there's like a shortcut for it. I just don't know it. For the longest time I've been using Eclipse, and I just started using IntelliJ like full time. Like I just put Eclipse on the side, and I've just been using IntelliJ, so I don't really know all the shortcuts yet, but I will. So public static final, and that's gonna be another string, and I'm just gonna be calling this token cannot be verified. So those are like some other string that I'm gonna need. Be verified, and I'm just gonna set it equal to the same string. So whenever I'm trying to decipher the token, if I can't, that means the token has been tampered with. I'm just gonna give him this message. I don't think this needs to be lowercase or uppercase. The next one is going to be I think that's gonna be the issuer of the token. So for instance, if you get a token from Facebook, you'll say Facebook and things like that. So let's define another string, and that's just going to be get raise, because we are the company sending the actual token. So let's just do, so whenever the token is issued, once you try to decipher the token, you will see all of this information. So you can see, hey, this was provided by Google or by Amazon or whatever. Next one is going to be the audience. Like this token is issued, but it's issued for what audience, like what kind of people. Like you can have one for like administrator or specific users, for like finance and things like that. So you can also check on that as well if you want to do some extra security. So if the token comes in, you want to make sure they're coming from the right audience, and you can check on that as well. That's just so many things you can check to validate a token. Beside, of course, deciphering it, make sure it wasn't tampered with. So all of those are optionals. You don't necessarily have to provide all of this information, but I just want to give you a very clean overview of the capabilities of what you can do. So let's do get arrays administration. Let's say this is for administration, and we're gonna set that equal to the same string. Or since this is gonna be used by like a user management portal, so we can just do user management portal. Okay, something like that. Really, that comes down to whatever you prefer or whatever you want to do. Another one we're gonna need. Let me do public static final. I think, yeah, there it is. That's how it's easy. Let's do string, and let's do authorities because I'm gonna need that, and you will see when I use that. And let's just call it authorities. And the next one that I need, public static final. Yay. Next one that I need is a forbidden message. So if, for instance, they provide a token, but they don't, they're forbidden to access the resource, I can just use this string to send them a message. So it's the string forbidden message. And I can say something like you need to log in to access this page, something like that. So just a message to the user that we're gonna send back if they're forbidden to access a specific resource. And next one, oops, public static final. What if I do S? Oh, cool. IntelliJ is really smart. Let's do another one for access denied. And this is going to be if they don't have access to access resource. So that's going to be access denied message. So if they don't have access to something, we can just pass in this message. So let's do something like you do not have permission to access this page, something like that. You can change this message to whatever you want, as long as it has something to do with accessing, because this is an access denied message, but you can change the verbiage if you want. Let's do another one for options. So public static final string. Yay. So let's do options HTTP method. So the reason I'm defining this one is because if the request method is option, like it's not get or post or anything like that, if it's option, I'm not gonna take anything. I'm not gonna take any action. I'm just gonna let it go through because I'm gonna explain why you should never, well, not never, but in this specific context, you don't stop the options, because the option will is the request that comes in to check to see what the server will accept or not. I'm gonna explain that more once I start using all of those variables. So last thing, we need public static final string, and that's gonna be the public URLs, and that's gonna be an array of strings. So let me put a bracket, and let's do public underscore URLs. So the public URLs, they're just going to be all the URLs that I'm gonna allow to be accessed without any security, and that's going to be like user, lowercase user login, right? Because we don't want to block the login, since that's how they actually have that's how they come to the application to actually get their credentials, not credentials, to get their token. We don't want to block the actual login page, and also we don't want to block the register. So the user register, we're not going to block that either. So we're going to leave this open. We're also going to leave open, let's do user reset password. and I'm gonna put 2 stars. So if they want to reset their password, we're gonna send them to this. And the reason I have 2 star after the last forward slash is because they're gonna go to this URL, and then here they're gonna be able to pass like myemail.com at something.com. So I have to say, hey, anything after this is acceptable. So any email, which I don't know what their emails are going to be, so I just put the 2 stars, mean anything after that, anything from this and whatever comes after that, I'm also going to allow. It's going to be part of the public URLs array. And I also want to not stop the images of the users so that when I fetch them, I don't have to provide any security. So I'm going to do /user /image and /*. Okay, so those are just I didn't really have to define all those constant. I just think it's cleaner, and you'll see when you do centralize your the different components of your application, it's a lot better, it's cleaner, and people can understand it better, and you have like one centralized like way to combine or put information that belongs together in the same place, and that's always good practice. So I define all of those variables so that I can use them in the actual provider that I'm going to use, and once I start using it, then you'll understand. It'll all make sense. But for now, just know that the expiration time is what we're going to use to set the expiration time on the token. That's going to be the token header. Actually, that's not the token header. That's the token prefix. So that's the token prefix. That's gonna be, this bare space is going to be in front of the actual JWT token. And I already explained that means that I don't have to do any further check for that token if someone try to log in with or try to access my application with that token. As long as they have the token, that should be fine. I should just take that token and then process it and make sure it wasn't tampered with or anything like that. I don't have to do any further check or anything like that. And this is our default or custom header, like HTTP header, that we're gonna use to attach the actual token to the header. And you will see how this is gonna be used very soon. So that's the message that I'm gonna send them when I can't verify the token, and that's these 2 are going to be the actual what gives you the token and what audience is for. So what gives you the audience is probably going to be the name of your company. That's why I put get arrays here, and then that's going to be the audience, which is going to be what application or who are going to be using that token. And this is, I guess this is supposed to be lowercase. So this is going to be all the authorities I'm gonna pass into the user. I'm gonna attach them to this string, and you will see that. So this string is gonna hold all of the authorities of the user, and those are just messages that I'm gonna send back. I'm gonna use if they don't have access or if they're forbidden to some resource. And this is the HTTP option method. I just don't want to type it in out, so I just put it in a constant, but you didn't have to do that. And these are all of our public URLs, meaning URLs that we're going to allow a user to access without being authenticated. We're just going to leave those open to the world because, of course, they need to be able to access the login page. We're not going to say, hey, you need to be logged in to access the login page. That doesn't make any sense. Or the register page, which is why I defined them here. So once I start using this in the actual token provider, then you'll see it all makes sense from there. Now that we have all of our constants that we're going to use in the provider so that we can generate the JWT token, we need to have a library that we can use to generate the token. Like right now, I don't have anything that I can use to generate the token. So we need to go grab one library that we need. It's going to be a dependency that we're going to put in the pump file, and that's going to give us access to a library that we're going to use. We're just going to leverage it to generate a token. So let's go ahead and do that. I have my browser open, so I'm just gonna do Java JWT. Now there are many different libraries that implemented the specifications of the JWT for Java. Let me look at the first one. I think the first one is the one that I want. So if we scroll down on this one, so let's see here, hold on. So it says Java implementation of JSON Web Token. Let me see, I'm gonna scroll down. We're gonna come back up in a minute. I just wanna make sure I got the right one. So let me open this link. Okay, so you can see this is from OAuth, and they're very they're very renowned in security and stuff with JSON Web Token. So I'm gonna go ahead and use theirs for the implementation, and this is their GitHub page. So let's scroll back up. So here's all the files. You can, it's, I guess, open source. All right, let me look at the license here. And you can see that's the dependency. I'm gonna make this a little bit bigger so you guys can see. So that's the dependency that we're gonna need to add to our pump file so we can have access to this library, and then generate the actual token that we need to generate, and all of the verification and algorithm use and all that stuff. And this is a little quick overview of how you can, so we're gonna need a secret of how you can generate it. So you can go through this. The URL is right here. You can go through it if you want, but I'm gonna show you how to use it. But if you wanna, have a first look at the documentation from the people who actually created this, you can. But I already went through it. Like I was using a different implementation. I don't remember from who it was, but it wasn't this implementation. And then I just started using this one. I mean, I don't know if there's any difference. I'm sure there is. So maybe one might be more secure than another. But I wasn't like building anything that was gonna go to production or anything like that. And I needed to make sure that it was a good implementation of the specification of JSON Web Token. But I trust the OAuth people. I think they know what they're doing. They have a great website, and they have great tools, and they have built very beautiful application security solutions. So I trust them. But again, depending on the size of your application, you might want to do a little bit of digging, or maybe even reach out to them, say, hey, I have some questions. But you can see how you can get the token and decode the token. And I already went through this, but I would encourage you to do the same. You can go through it just to see how they use it. The way that I'm gonna use it is not the only way to use it, but ultimately you're gonna do the same thing. You're just gonna generate a token and decode the token when the token is passed back to you. So you guys can go back and go through this. I'm not gonna go through it in this video, but I'm definitely gonna grab the dependency and go back to the project, and let's go to the pump file. Scroll down. Here's our pump file, and we can pretty much put it anywhere. So let's see, dependency. I'm just gonna place it right down there. Okay, so this is our dependency, version 3.10. So once we have that, we will have access to this library, and then we can start working on the actual provider, because we're gonna need this library first, which is why I'm doing this video first, so that you can see where I have this library, where did it come from, because if you don't have that, once you start coding and then you try to use the library that I'm going to be using in the provider, they won't come up. You won't have code completion, you won't have all the imports and stuff, so you need to have this library first. So now that we have the dependency that we need, that's going to bring in the Java JWT library that we need to generate the token. Let's go ahead and work on the actual provider now. So the provider is going to be what's going to be used to generate the token and do all the work relating to the token. So let me go here, and I'm just going to create a new package. I'm just going to call it utility. You can call this whatever makes sense to you. I'm just gonna call it utility, and then utility, I'm gonna create a new class, and that class is going to be the JWT token provider. So let's do token provider. You can call this whatever you want, JWT utility, or whatever makes sense to you. Provider. So JWT provider, token provider. Okay. So now what I want first is I want to bring in the secret. So the secret is going to be a string. It's going to be something very random, and that's what the algorithm is going to use to encode your actual token, so, and decode it or decipher or whatever it does. So let's do private, that's going to be a string, and let's say that's the secret. Okay, so this is the secret. Usually you would have this in some secure server, and then you would have it probably in your property file, like whatever property file you're using for the application, and then you would get that information anytime you need it from that secure server. So that's definitely something you want to keep secure, because if it's compromised, then your entire system is compromised, because then you know, all the token can be decoded, and they can see everything, all the information in the token in plain text. So you really want to keep this secret very secure and somewhere nobody can access it. So I'm gonna set this up in the actual property of the application. The reason that happens is because you can have like a property file for the application or configuration file for the application outside of the application bundle. So what I mean by that is you will build an application, right? And then you will bundle the application, meaning whenever you want to deploy, you're going to, for instance, this is going to be deployed as a jar. So you can take that jar and put it in a folder, and then inside that folder, you can have other configuration files, and depending on what you're deploying, you can deploy a specific configuration file. For instance, if I'm testing, I can have a configuration file for testing, and that configuration file can contain, you know, some dummy server or some dummy database or something like that. So once you have that information in a secure way, then, you know, it's harder for someone to access it, because they need to be authenticated sometimes to access the actual server, the secure server, and that's holding all the secret or in the very secure parameters that's used for maybe database connection and all that stuff. So that's why I'm showing you that best practice is to usually have this in a secure server somewhere, and then anytime you can have a configuration file that can access it anytime the application needs it. But here, you know, we're not really doing that. So that's going to come from the actual YAML file. So I'm just going to put the value annotation on this so that we can just grab that. And then I have to specify the name of the property in the properties file. So that's going to be JWT secret. Okay. So now we can have this name in the actual property file. So let's go back to the YAML file, which is our current property file, and then we can have JWT, and then underneath we can have secret, and I'm just gonna paste a random string. So this is something that you have to make very hard for someone to be able to guess, because it's supposed to be you know, some random string of characters that's really hard for someone to just guess if they're trying to break into your system. So you can put whatever you want. I would highly encourage you to for this to be something very secure. Like, it can't be like, you know, something like password or some word or something like that, because someone might have a system that can use some brute force attack, and then they just keep trying like actual word, and then they can break into your system or break your security. Okay, so that's just some random string that I just been using any time that I'm doing this. You can change it, it doesn't really matter. And I'm gonna show you why this is important, because we're gonna use it to verify our token once we create it. So this is gonna be our secret in the YAML file, and then the provider, we're just gonna access it that way. We just put the value and then put the name of it. So Spring will do its thing and then go into the properties file and look for that, and then pass it in here for the variable name. So the first method that we're gonna need is going to be the method to generate the token. So let's do public, and the token is a string, so that's gonna return a string, and let's call it generate JWT token. You can give it any name that makes sense to you. And this is gonna take a user principal, because whenever they log in, I'm gonna take their information, make sure they exist in my database, and then once I know their credential is good, then I can create a a user principal from Spring, which we created earlier. So we're gonna do user principal, and that's gonna be our user principal. So then what we want to do is we want to actually get all the claims for that user. So the user is going to come into our application. They give us a username and password. We say, hey, okay, this person is actually in our application. We recognize this user. Their password is correct. So once we know that information, we'll go ahead and take that information and create a user principal. This user principal is the user that is relating to Spring, right? So we'll take that user principal and then get all the claims for that user, meaning all the authorities or all the permissions. Okay, so let's create an array of string, and we're just gonna call this, let's call them claims, and that's gonna be, I'm just gonna create another method to get that. So get claims from user, okay, because that's what this is doing, and I can just pass the user principal, okay. And here I get this method. So now what I want to do is I want to go ahead and generate the token. So now I have the claims for that user that has successfully authenticated, because at this point they're past the authentication. They've been authenticated. I can say, hey, this person, they provide me good credentials. So now I just need to generate the actual token. So let's just return JWT. As you can see, we have the library coming into play. So JWT, and we need to create a JSON Web Token. So that's what this is going to be. So JSON Web Token that create. This is coming from the library. If you had a chance to go through the GitHub page, you would be able to see how to create that token. So what we have to do now, we have to pass in a bunch of information. So now we can do with issuer, and that's gonna be the issuer of the token, and of course that can be your company name or whatever the case might be. So I'm gonna do get underscore arrays. Well, I have to call in the constant first, so let's do security get array. So I pass in the issuer, which is the name of your application. So, and then I can pass in the audience. So with audience, and then here again I can call the security constant, and I'm just gonna call the audience that I defined, which is the administration. And then after that, I can also specify when this token was issued, which is very important because it's gonna look at that to determine if the token is expired or not. And then I can just say new date, which is from Java util. So right now, like whenever this token is being created, that's exactly when it's issued. And then you can change that date depending on your logic. Doesn't necessarily have to be now, but in most cases it's gonna be now. Next, we have to specify the subject, so we can do with subject, and that's going to be the actual user. That can be the username or some user ID or something like that. In our case, it's probably not going to be the name. It's going to be like some unique identifier that can identify the user in your database. So that's why it's usually not the actual name of the user, because you don't really care about the name of the user in this specific situation. So here we can get the principal that we brought in, and then we can just get the username from the principal. Okay, so we're gonna say the subject or the owner or the user for that token will be whoever that person is with their username. And then after that, we can pass in all the actual claims that we got for this specific user, because we passed them in this method that I still have to finish, and we get all the claims. So with those claims, we can pass them here. We can say, hey, this is the username, and that username has all those claims. So we can do with array claim, do with array claim, and then here I can pass in the name of the claim and the actual claim. So remember, we define security constant that's gonna be authorities, and we just have to pass in the actual authorities, which is claim. So let me put this on a new line. All right, so what we're defining is we say we're gonna create a JSON Web Token with this issuer, which is our company name, for this audience, which is the administration people. For you can think of whatever you want, but that's gonna be for this specific example, our administration, when it's issued, which is now. Create a new date object, and then the subject is going to be the username of the user, and then the claims, which is the authorities, that's going to be the claims that I got for that user here with their information, because this will contain the claim of the user. I just have to do some a little bit of coding and then get this claims and then pass them here. And then now what I have to pass in now is the expiration date. So I can do with expiration at, and then I can pass the new date, right? So I'll pass right now, and then I can pass in 5 days, which is coming from the security constant expiration time. Okay, so now that I have that, the only thing that I have to do now is to sign it. So I can go on a new line, and I'm gonna do sign, and I have to specify the algorithm. So that's gonna be, let's do 512. You can look at those algorithm. It's just the degree of the encryption and all that stuff, and you just can use whatever you want. I would definitely encourage you to use the most secure one or the latest one with the least vulnerability. And then in here we have to pass the bytes of the secret. So we can just call our secret. So secret that, and we have to get all the bytes from that. So that's how we're gonna generate the token. Gonna see if I can do some import on those. So we have this constant. We can go here and then just do dot and call on everything, and then we have to make this a static import static, and then we can just remove those like this. I know there is a shortcut to do this. I haven't memorized all the shortcut yet, so bear with me 1 second. And more action, import static. Okay, so here's the method that's gonna generate the actual token. So it's gonna go from getting the user principal after they've been authenticated. So after I verify their username and password, and then I get all their claims, and then with that claims, I generate the token by passing in the issuer, which is your company name, and the audience. So what audience is it for? Is it going to be for user in finance or user in administration? Here we just define administration. We set the date it was issued at. So with issued at, we take today's date, or exactly now, whenever this is being issued. We pass in the subject, which is in this case going to be the username. Again, this has to be a unique identifier for the user. It has to be unique. So that's why you can't use something like their name or their email or something like that. And then you pass in the actual authorities or permissions for that specific user. So all of this is going to be part of the token. So we name them authorities, and then we pass in the actual string array, and then we specify when this is gonna expire. So we're not gonna do new date, we're gonna do new date, and then we're gonna pass in the current time of the system that current times in millisecond. Okay, so we take the current time in millisecond, and then we add more to it. So that's what we're doing here. So this will be the method that's going to be responsible to generate the token with the user information and their claims, which is their permissions. You don't necessarily have to call this claim. You can call it whatever you want. Something like permissions or authorities. We define a name for it. So in an array, in the array, they're going to be named authorities. So it's going to be authorities. They're going to equal to a string of all the permission. And then we pass in the expiration time. So we take the current time on the system, and then we add 5 days to it. If you remember, in millisecond, we put 5 days, and then we sign it with the ECMAC 512 algorithm, and then we pass in our secret. So now we have a method that can return a JSON Web Token once we give that method a user principal. So we have the secret. Actually, I gotta fix this. I didn't realize that. So here we have to put a $, and then we have to put curly braces around this thing, like this. Okay, so that's how. So this method can actually generate the token once we give him the user principal after the user has been authenticated. And you're gonna see this in use once we build our controller and then we build the login page. So let me just finish this method. So for the claim, I just have to create a list of string. So let's do list string, and let's just call those authorities, right? Authorities. So let's just set this to a new string array. So that's going to be a new array list. So once I have this list, all I have to do now is to just get all the authorities from the actual principal. So let's just create a quick loop. So let's do for granted authority, which is what we're going to get. And let's just call them granted authority. And that's coming from the user that we're going to get here. User principal. I can just call it user. So let's say from the user, we can get all the authorities. So that's going to be a list. And then what we want to do, we want to add every single one of those granted authorities into this. So I'm going to copy this and do add, and then we pass in the granted authorities. And we need to get the authority from here because this returns an object. And when we do get authority, that's when we get a string here, as you can see, which is why I defined this as a list of string. Now all we have to do is to just return this list as a string array, which is pretty easy. So we're just going to return the authorities, and then we're going to call to array, and then we're just going to have to pass in the actual class of string, which is what we want. So we're gonna do new string and we'll put 0. Okay, so that's gonna make sure we return this as an array of string instead of a list of string. So now that we have this, we can go ahead and create the other methods that we're gonna need in this provider or utility class. So the next one is going to be to get the authorities from the token. So let's do public, and that's going to return a list of granted authority. So let's do list granted authority, and let's just call it get authorities. And this is going to take the token. So let's do string, token is a string, token. So from the token, we will need to get all the authorities. That's when the user is trying to access the information. We need to get the token and then determine what what authorities that they have before we can let them access certain things. So here, let's get all the claims. So let's do string, which is going to be an array. And let's just do claim. And we need to create another method that can get all the claims from the token, which is going to be a private method. So let's do get, instead of get claim from user, we're going to do get claim from token. And then we can just pass in the actual token. Okay, so that's going to give us all the claim from the token. And of course, I need to create this method. So I'm just going to create it down here just to get rid of this error. Okay. So once we have that, what we need to do now is to return all the list of authorities. So let's do return, and let's do a stream, and let's stream on all the claims, and then we can just map them to a new simple granted authority, which is something similar that we did when we were dealing with the user principal. So here we have to call map, and I don't know if you guys are familiar with Java 8. Import and import map. So I don't know how familiar you guys are with Java 8, but whenever you call stream, that means you're gonna technically loop over some collection, which is what this is. This claims a variable, it's a collection because it's an array, and I call stream, and I'm gonna start looping. Whenever we call map, it's because we want to transform every single item in the actual collection. So I'm gonna go through the collection, which is, you can think of stream as a loop, which is not exactly what it is, but it behaves similar. And then for the map, we're just gonna create a simple grant authority. So simple grant authority, and then we're gonna use a method reference, so new, and then we just have to collect all of this into an actual a list, because that's what we're returning. So we're gonna do collect, and then we're gonna call the collectors again, and then we're just gonna do toList. Okay, so that's what we need to do here. So as you can see, IntelliJ makes this return void, so it has to return an array of string. And let's just make it return null for now, because I don't want this to give me this red message. So, and then this is supposed to be collectors. So all I'm doing here is to create a list of simple grant authority, which extend grant authority, and I just create a new object of this type for every single claim that I have. So let me just create the get claims from token. So we're not going to return null, but we have to call the JWT verifier, which comes with the library that we get in the dependencies. So JWT verifier, that's going to come from it's going to come from our library, and then we're just going to call it verifier. And let's just do we need to create a method to get that verifier. So let's do get and I'm just going to copy this like this. So that's not going to take anything, and let me go ahead and create it. Create this method. Okay, so that's going to return a JWT verifier, and all we have to do now to verify the token is to just pass in the verifier, and then we're going to verify the token with the claims that we provided, with the name of the claims that we provided. So all we have to do now is to just return the verifier, and we need to verify the token. So that's going to be the token, and then we need to get all the claims. So we can do get claim, and then we pass in the name of the claim that we want, which is authorities, which is what we define as their name. And then since this is an array of string, we just have to turn this into an array of string so that we can return the actual type that we need to return. So as array, and then we just pass in the string class, which is what this is, an array of string. Okay, so that's all we have to do here so that we can get all the claims from the token, and that's just going to return a list of all of the actual token. Now for the verifier, again, we're just going to have to call the actual verifier from the library. So all we have to do is call verifier. We're going to define the verifier here, and then let's do a try catch, and let's do that. And so here all we have to do is to just call the algorithm that we use to decode the secret, and then with that algorithm we're just gonna pass it over to the JWT library so that we can get what we need. So let's just do algorithm, and let's just define this algorithm, and then we're just gonna set it equals to our algorithm, so which is MC12, and then we pass in the secrets that we define. And then with that verifier, all we have to do is to just call the verifier and then set it equal to JWT that require, and we pass in the algorithm, which is the one we just defined with our secret. And again, this is not magic. This is not something that I like studied by heart or anything like that. I just went through the documentation from the actual GitHub page, and then I just see how it works. They all do the same thing. At the end of the day, you can use whatever library you want. They will do the same thing. The only concern would be, do you trust whatever party created this library. That's the only thing. But they just do an implementation of the specification on how this thing is supposed to work. So that's all I'm doing here. So I'm not really doing anything specific. I've been looking at the library, I've used it, and then I just know how to use it. And then after that, we have to pass in the issuer. In this case, which is going to be the company name. So it's going to be the same company name that we specify, and then we just have to call build on that. Okay, that's it. So now we have the verifier. We can actually return that verifier. So after the catch block, and here we can just return the verifier. Okay, because that's what this is doing. It's just returning a verifier. And then here we can catch some an exception. I think the exception they have is JWT verification exception, and we're just gonna call it exception. And here we can just throw it in case something happens. So we can just throw the exception, which is a new this exception. If I want, I can just throw this because that's the actual exception. I didn't have to create a new one. But the reason I don't want to throw this exception is because I don't want to throw that back to the user, and then the user can see the inner workings of my actual application. So I'm just gonna create a new object and then just call in the token cannot be verified that we actually used. Okay, so that's why we created this. We're just gonna pass this string. So whenever this error is thrown, it's just gonna be, oh, this is the error, token JWT verification token exception, and it's just gonna pass in this message. It's not gonna take the message from the actual exception, which can reveal like critical information about the application and how we actually like define it. Okay, so that's why I'm doing it like this. I just throw some random string to explain what happened. So we can still use it as it is for now, but I want to just finish this altogether. So once I finish it, and then we're gonna go ahead and create the login. I still have a few more methods that I need to put in, but the video can't be too long. So I'm gonna stop the video now, and then I'm gonna continue in the next one. So right now we only have two methods in the provider. There's one to generate the token, and then there's another one to get all of the authorities from the token. We're gonna need a few more because the one at the bottom, the private ones, they're just helper methods. Like we're not actually gonna be able to use them because they're private, and we're not using them here. We're just using them, for clean code. We just define a specific method to do one thing. For the single responsibility principle that we know, you always have to try to follow. So now we have to create another method that's going to be able to get the authentication of the user. So the reason we need this method is because if I can verify that a token is correct, I have to tell Spring Security to get me the authentication of the user and then set that authentication in the Spring Security context. So I need another method that can get me the authentication when I pass in the user information once I verify the token. So let's do public. That's going to return the authentication, and I'm just going to call it get authentication. Get authentication, and it's going to take the username. So let's do string username, and it's gonna take the list of all the user authorities. So let's do list, and that can be a list of grant authority, and I'm just gonna call this authorities, and it's also gonna take the HTTP server request. So let's do request, and then here what I have to do in the body is to just call the user password authentication token from Spring. So username password authentication token, and let's do user authentication token, and then we just need to create a new object of this. So let's do new user password authentication token, and we have to pass in the principal, which is going to be the username, and then we need the credential. As you can see, it needs the credential. We don't need the credential at this point because we already verified the token. And then we can pass in the actual
authorities. So we're gonna do authorities. Okay, so I'm gonna put this on a new line so you guys can see it. Okay, so we call the username password authentication token, and then we pass in the username and the authorities. And now once we have this username password password token, we can just set the details on it. So username password authentication token, that set details, and you can read on what this is doing, but technically what it's doing is it's setting up information about this user in the Spring Security context. Okay, so set details, we're gonna call in the new web authentication detail source, and then here we just have to build the details for that user, and then in the context we pass in the HTTP servlet request. So we just say request like this, and then all we have to do now is to just return this authentication username password authentication token, which is what we call it right here. This has to be lowercase, and I need a niche. Anyways, you can call this whatever you want. I'm just give it a name. Okay, so that's what this is doing to get the authentication once we verify the token. Once we have this authentication, then we'll be able to set it to the Spring Security context to tell Spring to say, hey, this user is authenticated, process the request. That's what this is doing. And then I need another one to check to see if the token is valid. So that's the public. Of course, it's gonna return a boolean because it's checking for true and false. And I can do is token valid or something, whatever you want. And then here I need the username, of course, and then I need the actual token to do that verification. And then here for the body of the request, what I want to do again is to call the JWT verifier. Oops, and JWT verifier, and you know how to get the verifier. If you remember, we define this method right here to get the verifier, so we can just call this method, which is going to give us the verifier. Once we have the verifier, we can actually use it to check to see if the token is valid. So all we have to do now is to do, let's do return. So we also have to make sure that this username is not null or it's not empty or anything like that. And there's a library that we can use. I mean, we can do this ourselves in Java, but there's already existing library to do this. And I'm going to show you a very good one that's also very popular that you can use to check to see if a string is null or if it's empty or anything like that. So let's go over to the browser, and I think I'm looking for string util Java, which is here, and we need the Maven dependency. So let's do Maven, and here it is, and we need this dependency. So let's just copy it. As you can see, I'm gonna make this bigger. From the Maven repository, I just grabbed this, the version 3 of the string util, which is coming from commons-language 3. So we're gonna go back to the application, and let's go to the POM file, and here we're just gonna paste that here, and I'm gonna remove this comment. I don't really need it, and that should be everything we need to do here. Okay, so let's close that, or just go back here. So now we can actually use string util. You can do string util, this one, which we just installed, coming from Apache Common Language. Language 3, and then we can check to see is not empty. So you can see on the right here is not empty. It's going to check for null, empty string. If there's anything in it, even if there's space, it's going to return true. So that's why this is so handy, and we're going to use it throughout the application. It's going to be very interesting. It's very popular. The Apache library is very, very popular. Like, I can't think of any Java developers who doesn't know the Apache Common Library. So we want to check to make sure if it's not empty, which is this one. I'll check for null. I mean, they're very similar, but let's just go with it's not empty, and then we pass in the username. So it's going to return true or false depending on if it's empty or not. And also we want to make sure that the token is not expired. So let's do is token
expired, and that's gonna be another method, private method that we're gonna use. And it's gonna take the verifier, and of course it's gonna take the token. And since we don't have this yet, so let's go ahead and create it down there. And all we have to do in this method is to just create check the date to make sure it's not after the expiration date of the token. So this is a very short one, so let's do it real quick. So let's do date expiration, and we need to get that from the verifier. So let's do verifier, which we got from here, and we need to verify the token, and we pass in the token. Oops. And then here we just get the expiration date. So get expires at. Okay, that's gonna give us the date the token is gonna expire. All we have to do is to make sure that we're not past the 5 days at this current moment when this method is executing. So all we have to do now, since this returns a boolean, so we can just do return, and we can just take the expiration date, make sure it's before 2 days. So we can just do before, and then we pass a new date in here. That's all we have to do. So this is gonna return true or false, whether this is before or after. So this, and since here we check to make sure it's not expired, we just have to put exclamation point here. That's gonna do the trick for us. It's gonna reverse this, because if it's expired, this is gonna return true, and we want it to be false here for our logic, because we don't want it to expire. So last one, we need to get the subject. So let's go ahead and create another public method. The subject, remember, is a string, so we're gonna do string and get subject, and all we need now is the token. So we're gonna do string token, and from there we just have to get the verifier again. So I'm just gonna get this line just to get the verifier. And then with the verifier, I can get the token by just verifying the token and call get subject on it. So I'm just going to return this verify the token. So we have to make sure the token is correct. And then we call get subject. As you can see here, you can check to see all the method that exist inside this verifier. So I think for now, I don't think I'm missing anything. I think that's all we're gonna need for the provider, the JSON Web Token provider. I want to turn this into a component so that it can be skinned by the Spring. So component. So whenever the application start, I will have a bean of JSON JWT token provider. Okay, so I think I will put a space here since this is the only variable. So again, we have our secret coming from our YAML file, which we have to keep secure, which is this one. So again, we have one to generate the token. So once they log in, we validate their token, validate their credential. We can give them a token, pass it in the header, and you'll see how this is going to be done. We have another one to get the authorities, get authentication, and another one to check if the token is valid, etc., etc. So I think for now, that's all I need in the token provider. Maybe I'm forgetting something. If I'm forgetting something, then I'll figure it out later, and then I'll come back here and then put it in. If I'm start using the controllers and things like that, I'm like, oh, I need this other method that I forgot to put in. But I think I got all of them. So if we miss something, we can just go back and put it in there. And of course, this is bound to grow. It's probably gonna grow as you have more specification, or you might have to create like another one, or maybe change this name to be very specific and then create another one in the same package and things like that. So things will vary over time. So there's nothing like set in stones or anything like that. If you forget something, you can always go back and then change it. You might want to try not to do that. From the get-go, you want to make sure everything is like perfectly laid out and everything like that. But you can still go back and make changes. So at this point, we have our JWT token provider that we can use to generate tokens, verify user token and user information and things like that. Now, what we have to do now, we need to have a way to stop users who are not authenticated, or if they have a bad token, to access the application. And that's when the idea of filters come into play. So when we talk about filters in this context, it simply means that when a request comes into the application, it's going to go through a series of filters, and then we can do a lot of checks during this time. So while the request is going through the filters, we can check to see like if the token is valid, is the username is correct, and things like that. And then we can either say reject the request or accept the request and process it. So this is the whole idea of filters, which is have like a line of defense before we actually accept the request. So we need to build a filter that can take every request that comes into the application to make sure that they come in with the appropriate token and that this token is valid. And then we can verify the user and then set the user as an authenticated user. And that way the request can go on and be processed. So let's go back here in the main package. I'm going to go ahead and create another package, and I'm just going to call it filter. So in the filter package, I'm just going to create a class, and I'm just going to call it JWT Authorization Token. Authorization, not token, filter. Okay, so JWT Authorization filter. So this filter is to either authorize or not authorize any request that comes in, any request, but it's only gonna do that once. It's not gonna do it multiple times. So for this, we need to extend a very handy class called once per request filter, which means whatever is gonna be happening into this class, it's gonna happen once. And if we have to extend this class, then we have to implement a method called doFilter internal. Okay, so this method is gonna fire every time a request comes in, and that's only gonna happen once. Okay, so here we need to bring in our JSON JWT token provider. So it's the private JWT token provider, and we're just gonna call it JWT token provider, and then we can pass it in the actual constructor of this method. So I think if I do alt insert, and then I can do constructor, and I can do that. Okay, so I don't have to do this I know. So we pass in the provider into the constructor, so whenever this class is constructed, we will have a JWT token provider available that we can actually use in the application. So in the doFilter method, for our purposes, all we have to do is to check to make sure that the token is valid, the user is valid, and then once we can verify that information, we're just gonna set that user as the authenticated user. Okay, so as you can see, this method is very handy. doFilter internal, we have the request, the response, and the filter chain, so that we can pass in the request whenever we're done with it. So what we have to do now, we have to take that request and make sure that the method is not option. So the reason we have to do that is because whenever there is a request that goes into the server, the first request goes, so for instance, let's say I issue a request to, for instance, get users, right? So before this is issued, the get is issued to get the users, there's an option, like the same request but with a different method. So that what the purpose of this is to find out information about the server, what the server accepts, and headers and things like that. So that's why whenever the request comes in and the request is for the
the options method name, then we're not going to do anything, because we just want this to always go through so that the client can collect information about the server, so that they can handle everything the way that it should, because it needs to know what the server accepts and what the server doesn't accept and things like that. It gets a little bit more complicated than that, but I don't want to go into all the detail. But the point is, if it's options, which is a request that gets sent before every request to collect information about the server, we have to let it go through. So all we have to do now, I'm just gonna call this request, this name is too long for me, and response. Easier and more to the point. So let's do if the request, right? So request, and I can get the method, get method. Okay, that's gonna return either get, post, or options, or delete, or something like that. And then we can check to make sure this is equals to, let's do equal ignore case, because it can be uppercase and lowercase. And then we can call the security constant, so that option HTTP method, so which is going to be right here. Okay, so if it's option, in that case, what we want to do is to just let it go through. We're just gonna do response, and we set the status. So set status to OK, which is coming from Spring HTTP status from Spring.OK. Remember, we looked at this class, and then we need to get the value, which is gonna give us the actual like number. And here we set the response to OK. And then after that, we can go ahead and check to see if it's not option, and then we can put in our logic. But before I do, let me see if I can do some static import here. So I statically import those values so our code can look nicer. Now I have to do else in case if it's not option, so in case it's like a get request or a put request or whatever else the case might be. So now I have to make sure I can get the actual token. So let's do string authorization header, because the token is going to be in the header. And then here we can call in on the request to get the header, and then the header that we want is the authorization header, so we can do authorization. So let's do HTTP headers from Spring, HTTP headers that authorization. That's the one that we need. Okay, we're looking for the authorization header. So that's gonna give us a string of the actual authorization header. So then we can check to make sure it's not null. So we can do if the authorization, right, header that we got, if it's null, or if it doesn't start with the token prefix, which is bare, then we don't necessarily need it. So we can do if it's not null, or if it doesn't start with the actual token header, which is bare. So to start with, and then we can pass in the token header, which is coming from our security constant that token prefix, not header, prefix. Okay, so we pass in the prefix. So if this is not the case, then we know this is not the authorization headers that we're looking for. Maybe there's like a separate one, authorization headers, but it's just not ours because it doesn't have the prefix bare in front of it. So in that case, then we can just call the filter chain, and then we just do filter, and then we pass in the request and the response, because we're not doing anything with the request anymore. And then after that, to stop the execution of the method, we can just do return, and then we don't return anything. So that at this point, then after this line, the method would stop executing and it won't go through all the other logic. So again, just to recap, when the request comes in, we're just gonna go ahead and check to make sure that it's not option. If it's option, in that case, we just set the response to OK, because we're not doing anything.
Otherwise, we're going to try to grab the authorization header. So we get the request, and then we call get headers. We pass the headers name that we want. Let me see if I can do a static import for this. So we pass in the actual authorization header, which is what it's going to be, the authorization header. And then we make sure that the authorization header is now null, or it doesn't start with the prefix, because if it doesn't start with the prefix, then we don't care for that authorization header. We don't know what it is, but we're not going to work with that. We're only going to work with the one that starts with barrier. Okay, so if that's not the case, then we just pass in the request, meaning when we do filter, we pass in the request and response. We just let the request continue its flow, and then after that we just stop the execution of the method by just calling the return and then not return anything.